Yeah, let's starting. In this session, we are going to start Spark Core programming. We have discussed, we have discussed Spark Core is heart of Spark application. Yes or no? Spark Core is main component of Spark. Spark Core is main component of Spark. In this Spark Core, we do what? RDD programming. We write RDD programming. In Spark Core, we will write RDD programming thing. And we have different components. We have different components. Spark SQL, Spark streaming, let's say Spark SQL, Spark streaming. We have different components like Spark SQL, Spark streaming, and Spark mlib. Next one we have Spark graphics. Right, team? All these components works on top of Spark SQL only, Spark core only. Yes or no? All these components works on top of Spark core. Yes or no? So if you are when you write a Spark SQL, all Spark SQL statements converted into RDD programming. When you write the Spark streaming statements, internally Spark streaming statements converted into Spark core programming means RDD. When you write a Spark mlib or Spark machine learning library, these statements also internally converted to Spark RDD. Spark graphics. Spark graphics also internally converted into these statements internally converted into RDD program. So Spark core is heart of Spark programming. So Spark core is main component. Spark core or in Spark core, we write RDD programming. We write RDD programming. So RDD stands for resilient distributed data set. Resilient distributed data set. So in RDD we write in Spark core we write RDD programming. So this RDD programming we can implement using RDD programming using Java language, using Scala language, and using Python language too. Using Python language, RDD programming we can implement using Java language, Scala language, and Python language too. In Spark core, Spark context is heart of Spark context is heart of Spark core, heart of Spark application, or we can say it is starting point of Spark application. Okay, so in Spark core, first we will create a Spark context object. First we will create Spark context object. Spark context object. There is no space team. Spark context object. After that we will use RDD as a storage. So this is first we create a Spark context object. After that we will create we will create RDDs. We will create RDDs RDDs and we will perform RDD programming. We will write RDD programs. We will write RDD programs. RDD statements or RDD programs. So in RDD program we have concept called transformations and actions. RDD programming nothing but transformations and actions it is. So first in Spark Core programming, what we will do, we will create a Spark context object. Once we create a Spark context object, then we will create RDDs. On top of RDDs, we will perform RDD statements, RDD operations, we can say programs instead, RDD operations. So RDD operations are two. We have transformations and actions. So which is starting point of Spark Core programming? Spark context is the starting point of Spark Core programming. Okay, clear writing? Okay. So first we are discussing Spark Core programming introduction. Now let's understand Spark context. Spark context is a starting point of Spark Core application. Spark Core application. Starting up Spark Core application. So we will create Spark context object. First we will create a Spark context object. First we will create Spark context object. Okay. Then we will load file. So this Spark context class contain different functions. Spark context class has different functions to create an RDD. So first one we will create a Spark context object. Then once we create a context object, then we will load file. For loading Spark context object, for loading file to create RDD, we have a different functions to load file and to create RDD. To load file, to load file and to create RDD. To load file and to create RDD. Spark context class has first one text file function. Second one whole text file function. Whole text files function. And third one parallelize function. So these are the three important functions to create an RDD. These are three important functions to create an RDD. Okay. So this predefined class presented in PySpark package. This predefined class presented in PySpark package. Let's see it. First one, creating SparkContext object. How to create SparkContext object. How to create SparkContext object. First one, we need to import a package. So first one, import PySpark package. In this package, import SparkConf and SparkContext. First import two classes. Once we import these two classes, first one, we will create a configuration object. Step 1, importing packages. Step 1, import package. Step 2, create a object. So here, first we will create object of configuration class. Conf equal to SparkConf. And by using Spark configuration class, we will set configuration details. We will set configuration details of Spark application. So first we will set configuration details of Spark application. So here we use conf dot set master is a predefined function. Here we set master name. So master name, we can use local, or we can use Spark standalone master, or we can use yarn master, or we can use mesos master. So we can use any master details we will pass here. Second one, once we create master name, then we set application name. Configuration dot set app name. Set application name. So you can give application name. So next one, once we set master name, once we set application name, then we will create object of SparkContext. So we create object like sc equal to SparkContext. Then we pass configuration object. We create the Spark configuration object. Next one, step 3, set log level. So by default, it will display all logs. By default, it will display all logs. So if you want to only warning logs, we have to set. So if you want only warning logs, if you want only warning logs, warning logs, then we use sc.set log level, sc.set log level, sc.set log level, we pass warn. We pass warn. So in this way, we create a SparkContext object. In this way, we create a SparkContext object. So SparkContext object is a starting point of any Spark application. First, we will create a SparkContext object. After creating SparkContext object, we will load file. Then we will create RDD. So we will create a SparkContext object in this way. First, we create a configuration object. So these configuration object, context object presented in this package. So first we will import this package and we import this corresponding classes. Then we will create a configuration object. Then we pass configuration object to SparkContext object. Then we set log level. Log level is optional. If you not set log level, it will display complete logs. Debug logs, warning logs, info logs, error logs. So sometimes our output to mix with this logs. So to avoid that one, we display only warning logs. So for that one, we are using sc.set log level, and we are passing warning. Now let's understand RDD. RDD stands for Resilient Distributed Dataset. Resilient Distributed Dataset. Distributed Dataset. It holds the data. It holds the data. It holds the data. It holds the data. So data splits into multiple partitions. Data presented in RDD, data presented in RDD, data presented in RDD splits into multiple partitions. Multiple partitions. Data presented in RDD splits into multiple partitions. So main purpose of partitions are parallel processing. Main purpose of partitions are parallel processing thing. Okay. So to create RDD, Spark class has different methods. Sorry, SparkContext class has different methods. Different methods are functions. Let's say we have SparkContext has these functions too. So to create RDD team, to create RDD, SparkContext class has these three functions: text file function, whole text file function, and parallelize function. So main purpose of RDD is storing the data. Main purpose of RDD is storing the data. We can store huge volumes of data. So it stores what? Huge volumes of data. It stores any size of data type, any size of data. Then it will distribute the data. It will distribute data into multiple partitions. So once we store data into RDD, that RDD divided into multiple partitions. RDD divided into multiple partitions. Each partition stores in different mission. Each partition stores into different mission. So to create RDD, we use what? SparkContext class functions. We have text file function, whole text file function, and parallelize function. Let's understand different ways of creating RDD. First one, by loading file, by loading file. Second one, by converting local collection. Local collection means list, set, tuple, comma, dictionary. By converting local collection into RDD. Third approach, by applying any transformation. By applying any transformation. So there are three ways to create. RDD. They are: first one, by loading file. Second one, by converting local collection. Third one, by applying transformation. So first one, we are going to see in interactive mode. And the next one I am going to show in script mode. So here script mode I use PyCharm. Interactive mode I can use either PySpark Shell, or we can use Jupyter Notebook. We can use either PySpark Shell, or we can use Jupyter Notebook. Okay. So first one, by loading file. So first approach is by loading file. Let's understand team creating RDD by loading file. To create RDD, we use by loading file. We can create RDD. This approach we are seeing. First one, to apply this process, Spark class has SparkContext class. SparkContext class has two methods. SparkContext has two methods. One text file function. Second one, whole text file function. So these are the two functions we can use to load file and to create RDD. So first one, let's see team, text file function. Text file function. Text file function. It will take path. It will take path. So it will return RDD. It will return RDD. RDD equal to text file sc dot text file. So Spark context reference dot text file, and we pass path. This path may be here. Path may be here. Path may be local file system. Path may be local file system or HDFS file system. HDFS file system or S3 file system. S3 file system. So S3 is a AWS file system too. So you can specify local file system path or HDFS file system path or S3 file system path. Okay. So example 1 I am taking. Example 1. Load local file. Load local file. Local file and apply processing. Apply processing. So this is our requirement. Load local file and apply processing. So first one, I am opening command prompt, interactive mode. I am opening command prompt. I am typing PySpark. PySpark. When you type PySpark, it will start what? Interactive cell. Let's wait it. So it is started Jupyter Notebook. It is started Jupyter Notebook. See, why it is started Jupyter Notebook means we configured PySpark with Jupyter Notebook. Let me open add system settings, environment variable. Okay, here we created PySpark driver equal to Jupyter. PySpark underscore driver underscore path we created notebook. Okay, click on. So because of we configured PySpark with Jupyter Notebook, whenever we type PySpark command, it is open Jupyter Notebook. Click on Python 3. Let's say I have a data in C family. I have a data. In this data, I have a comment file. Let me open. This is my comment file. It has 4 records. So what I'm doing, first one team. First one, Jupyter Notebook. Jupyter Notebook. So we are executing in Jupyter Notebook. We are executing in Jupyter Notebook. It is a interactive mode. Interactive mode. It is a interactive mode. Here Spark context object is already created. Spark context object is already created with SC reference variable. With SC reference variable. Let me show in Jupyter Notebook. Print SC. You will get Spark context. Master is local. Application name is PySpark cell. So SparkContext object is already presented. Okay. Now loading file using text file function. So sc dot, you can type sc dot tab space. It will list all functions presented in SparkContext. Let's say text file. Then here we pass path of our local file. So this is our local file system path. This is our local file system path. File name is comment.txt. So in double quotes in Python, in double quotes, if you use single path, it will expect formatting characters like /n/t. Okay. So to give indication to Python, this is not formatting character, this is a path separator. We use two forward slashes. Two forward slashes. So sc.text file loads this file and returns RDD. Then we are creating one reference equal to R1. R1 equal to sc.text file. Once it is created RDD, we are applying RDD operations. R1 dot count. Print R1 dot count. So print R1 dot count. So printing number of records. Let me write comment. So print number of records. Second one, to print all the rows. To print all the rows. To print all the rows, we use for v in R1 dot collect function. Collect function returns all the rows. Colon print v. Print v. To print only required records. To print only, to print or access only specified number of records. Number of records we use for v in R1 dot take of two records. Two records colon print v. So here all the location I am using print star into 20 times. Into 20 times. After printing count, I am printing star 20 times. After printing all the records, I am printing star 20 times. Okay. Now let's execute it. So total number of records are 4. We are printing all 4 records. We are printing only specified number of records. Okay. So next one in PyCharm. In PyCharm. Let's understand same example in PyCharm. In PyCharm, it is a script mode development environment. Script mode development environment. Script mode development environment. Here we have to write everything. We have to write everything. Everything means we have to create SparkContext object. SparkContext object. SparkContext object, etc. So everything we have to write. Interactive mode, it will create a SparkContext object. So let's understand steps to write. Step to write Spark Core application in PyCharm. PyCharm. Steps to write Spark Core applications in PyCharm. Step 1. Step 1. Start PyCharm IDE. Start PyCharm IDE. Step 2. Step 2. Create a project. Create a project. So first one, let's start PyCharm IDE. Okay. So click on PyCharm IDE. Click on PyCharm IDE. It will start PyCharm IDE. Then next we are going to create a project. It may loading some other project. So we are going to create a project. So let's say, let me load team. Once it is loaded, we are going to create a project. Yep. So go to file, click on new project, click on new project, select the project location, select the project location. Okay, here I want to create a project is Spark Core. Spark Core. Click on. So project interpreter is Python 3.7. Okay. I want Python 3.7. Click on create. Yes, open in this window. So first we created project. Next one, step 3. Step 3. Create a Python file. Create a Python file. Create a Python file. Let's go to PyCharm. Let's wait team. It is processing. Let's wait to process. Once it is processed, it will create a PySpark project structure, or simply we can say Python project structure. So create a Python file. Step 4, write PySpark application. Write a PySpark application. So here we have steps, different steps. First step is creating SparkContext object. Let's see it. Let's wait to start. First time it will take a few minutes time. Once project created successfully, next time if you open this one, it won't take much time. So so we created project. Now let's create a Python file. So go to Spark Core, right click on this Spark Core, click on new. Here we see Python file. So I am writing create RDD, create RDD by loading file, dot py. Create RDD by loading file. So once we create a file, then write the PySpark application. So first one, PySpark application, I said first by creating SparkContext object. PySpark application starts by creating SparkContext object. So first one, we import a package. Step one in create an app application. Step one is creating or importing SparkContext object. Next one, so by creating SparkConfiguration object. SparkConfiguration object. Next one, step two, creating SparkContext object. SparkContext object. This one, importing packages. Import packages. So here I am creating Spark configuration object. Next I am passing master name. Master name I am passing. Let me go to PyCharm. Here master name I am passing local of star. Local of star. Okay. Next one, application name. Application name. Here I am giving application name is first Spark Core. First Spark Core. Okay. Next one, create a SparkContext object. Create a SparkContext object. Create a SparkContext object. Next one, set log level. Set log level. Once we create SparkContext object, then we create RDD object by loading file. We already created here, right? Let's use this approach. Remaining operations are this one. So step 3. Step 3, apply processing. Apply processing. So these are the operations we are writing. If you observe above here, importing PySpark SparkContext giving red mark means errors. So we return program, but it is giving error. It is giving error. So step 4 we return. Step 5 here. Step 5, add required PySpark library. Add required PySpark libraries. Add required PySpark libraries. Okay, go to Spark project. Go to Spark project. Select Spark project. Go to file. Go to settings. Go to file. Go to settings. Go to project here. Expand the project. Here we see interpreter. It is selected Python 3.7. Click on project structure. Click on add root content. Add root content. Go to PySpark installation. In my system, I installed F drive, software. Under software, we have a Spark. Under Spark, we see Python. Under Python, we see lib. Select these two libraries. So add required libraries. There are 2 libraries here. So first library name py4j. First library name py4j. Next one, PySpark library. Next one, PySpark. Okay. Are you seeing 2 library names here? Select these 2 libraries. Click on OK. Click on apply. Click on OK. Let's wait. These red marks will go out. Still we are getting red marker. Sorry, here we use from, not import from. So here I did mistake here. First one, we use library name here from library or package import classes. So that's it. So after applying all these five steps, so our program completed successfully. Now step 6. Step 6, run. So right click on this program team, run, create RDD by loading file. See, it is providing development area, it is providing runtime area. It is providing both development area, runtime area thing. Right? We got output, right? So we got output, right? Total 4 records. We loaded file. Total 4 records we displayed. Next we displayed only 2 records. Yes or no? So whatever the processing logic we applied, based on that processing logic, it has displayed output. So today we seen loading file, we created RDD. We seen 2 environments. One interactive environment using Jupyter Notebook, script mode environment using PyCharm IDE. Let's start in. We seen previous session, we seen creating RDD using local file. So creating RDD using local file, right? So in this session, we are going to see creating RDD using local collection. So first one, creating RDD using local collection. So let me write logic to create RDD using local collection. So first one tip, second approach, this is second approach. Yes or no? This is second approach. So we seen first approach is creating RDD by loading local file. Second approach we are seeing creating RDD by using local collection. First one, I have a collection list using some values 10, 20, 30, 40, 50. This is my local collection. I want to create an RDD. So R1 equal to SparkContext dot, click on tab space. It will display list of functions. In this parallelize function, you can pass local collection. Then print number of rows. Each data item is converted as a row thing. So we have 5 items. In RDD, it will convert to 5 rows. Okay. Now print R1 dot count. Count is a action. It will display number of rows in a RDD. Returns number of rows of RDD. So next one, I want to print all rows of RDD. Print all rows of RDD. Then we use for v in R1 dot collect. So here R1 dot collect function reads all rows of a RDD. Then each time it will store in one row. Then we are going to print that row. Print v. So we are printing first row. Next iteration it will read second row, stores into v. We are printing second row. Next iteration it will read third row, printing third row. Next iteration it will read fourth row, printing 4th row. Next iteration it will read 5th row. We are printing 5th row. Next iteration there is no value in RDD, then it comes out of for loop. Out of for loop I am printing star 20 star I want to print 10 times. Then again print specified number of rows. For this one we use take function. Take, and we pass number of rows we want. I want only 2 rows. It will print only 2 rows. Let's execute this program. Yes, sir. Let me print this one after count. Shift enter. Number of rows are 5. So first time we printed all 10 rows. Later we printed only specified rows. Yes or no? So we can convert any local collection. This is list collection. You can convert to tuple. Let's take one more example. So here I want to convert to tuple. I have a tuple T1 equal to, I have a tuple with some values 1, 2, 3, 4, 5. I am passing tuple as a input to this parallelize function. Then shift enter. So by using parallelize function, we can convert any local collection. Here local collection means Python collections. So creating RDD by using local collection. Local collection means Python collection. So in Python we have we have list, we have tuple, we have set, we have dictionary. Dictionary thing. So these are different collection frameworks. Okay. So you can pass any collection framework. Parallelize function, SparkContext class parallelize function convert to local collection into RDD. Okay. So Spark class has SparkContext class has parallelize function. It will convert local collection into RDD. Local collection into RDD. Okay. So next one. Let's say we are going to create RDD by performing transformation. Third approach. We seen how to load local file, create RDD by loading file. First approach is completed. Second approach also we completed. Creating RDD using local collection. Now let's see creating RDD by performing transformations. In Spark Core, we have different transformations. We have different transformations. We have different transformations like map, flatMap, etc. There are plenty of transformations. By using any transformation, we can create RDD. One important point to team: transformations we can apply on RDD. We can apply on RDD. Every transformation returns another RDD. Every transformation returns another RDD. Every transformation returns what? Another RDD. So let's say creating RDD using or by performing transformation. Let's see one example here. Let's see one example. Let's see. So first I am creating a RDD. So I am creating RDD using parallelize function. So first one thing, I am creating RDD using parallelize function. I got an RDD. So I am applying transformation on RDD, R1 dot map transformation. We will discuss clearly what is map transformation in transformation concept. Let's observe. I am applying map transformation. So it will read each row. And passes to lambda function, custom function. In this custom function, each row. So this one converted to each row, right? So first it will pass 10. What I am doing? 10 plus 1, 11. I am returning 11. So final returned value we are storing into new RDD. Okay. Let's see. Print before transformation. Before transformation, I am printing R1 RDD data. So for V in R1 dot collect V. Next one, print V. Next one, printing after transformation. After transformation, R2 dot collect. So middle I am printing this star. And let's execute this program. See team, before transformation, R1 RDD data is 10, 20, 30, 40, 50. After transformation, 11, 12, 31, 41, 51. Means every transformation returning another RDD, right? Yes or no? Every transformation returning another RDD. So we can create a new RDD by using transformations. We can create a new RDDs using transformations. So this is the example. Okay. Let's say in this session, we are going to create an RDD by loading HDFS file system. So first, we are going to perform 4 steps in this example. First, we will start Hadoop system. So this is my Hadoop mission. There is a command called start-all.sh. So first we will start Hadoop. Next one, we will verify Hadoop. So start Hadoop, start-all.sh. Second one, verify Hadoop. Verify Hadoop. Start Hadoop. Okay, we use this command. Verify Hadoop is started or not. We use JPS command. To stop Hadoop, we use stop-all.sh. So we use this command type to stop Hadoop. So to stop Hadoop, we use this command. So we started Hadoop. Then let's verify JPS command. Node manager is running. Resource manager is running. Name node is running. Data node is running. Secondary name node is running. All daemons are running. Let's find IP address. IP space ADD space show. And this is our Hadoop mission IP address. Let's copy this one. Let's open any web browser. See here, we are using Hadoop 3. So name node URL is IP address colon 9870. So here we click on utilities, browse file system. So here we have only root file system. There are no files and directories presented in this Hadoop directory. So next one tip. Next one, file should be present in HDFS file system to create an RDD. So what we are doing here, we are creating creating directory. First step, creating a directory in HDFS. Creating a directory in HDFS, we use Hadoop fs-mkdir. I am creating root. Under root, I am creating C family directory. So let's execute this command. Let's verify in name node URL. Refresh. So C family directory is created. Next step. Second step, create a local file. Create a local file and upload into HDFS file system. Okay. So here we are creating local file cat greater than comment. Here I am creating local file Hadoop HDFS Hive Spark Hadoop Hive Hadoop HDFS Spark HDFS Hive Spark. So I have a 4 rows. Control D to save and come out from local file creation. First one. Then I want to put this file into HDFS file system. Hadoop fs -put and our file name is comment file. I want to place this file under root under C family. So file name, giving file name is optional. If you not give file name, it will write a file with local file name. So let's go to HDFS file system, click on C family. It is created comment file. Okay. So comment file is successfully created. So we placed local file into HDFS file system. So second step also completed. Now coming to third step, write a PySpark statements to create RDD by loading HDFS file and apply processing tip. So we started already PySpark. Let's go to browser. It is open to Jupyter Notebook. So we already created RDD by loading local file. We created RDD by loading local collection. Now team, we applied some transformations. So now let's see creating RDD by loading a local file. We started Hadoop. We placed local file into HDFS file system. File is presented. Now we are writing statements to read or create RDD by loading local file. So we have Oracle VM VirtualBox. In this VirtualBox, I have a CentOS 7. In that I have Hadoop. In this I have a root user and C family user. For both users, password is C family. Okay. So IP address of my virtual machine is 192.168.225.152. Okay. So HDFS :/192.168.225.152. Here we have a port number for name node we given 9000. In that root directory, under root directory we have C family. Under C family we have a comment file. So by using sc.text file, we are loading this HDFS file. This file reads HDFS file. This function reads HDFS file and creates a RDD. We are creating one reference variable to point to that RDD. Then we are displaying number of lines of this file. How many rows are presented in this file? Total 4 rows. Yes or no? So we are displaying count. Next we are displaying 4 rows. Next we are displaying 2 rows. Let me execute to shift enter. Let's see here it is processing. Let's wait. Once, yeah, it is started processing team. Yep, successful. So it is connected HDFS file system. It displayed a number of rows. First we are displaying all the rows. Next we are displaying 2 rows. Yes or no? So that's it for loading HDFS file system into RDD. Loading HDFS file system into RDD. Clear, right? Yep. Let's start. RDD operations. What are RDD operations? So we understand RDD means resilient distributed data set. Resilient distributed data set. Distributed data set. So it holds data. Yes or no? It distributes data into multiple machines. So on RDD, once we create RDD, so how do we create RDD? How to create RDD? We understand. First one, by loading file. Yes or no? Second approach we seen by converting local collection, by converting local collection. So next one we seen by performing transformation. Yes or no? By performing transformation. So we can create RDD. So once we create RDD, then we can apply RDD operations. So there are three types of RDD operations. There are two types of RDD operations. There are two types of RDD operations. They are first one, transformations. Converting RDD from one form to another form. Converting RDD from one form to another form is called transformations. Second one, actions. Second one is actions. What is action? What is action? Action returns results. Action is an operation. It will return results. So on RDD we can perform two types of operations, transformations or actions. Simply we can say this is RDD programming. RDD programming means applying transformations and actions. Applying transformations and actions on RDD. On RDD called RDD programming. So this RDD programming, we can implement using Java language. We can implement using Scala language. We can implement using Python language. So Spark provides API for only these three languages. RDD API is available only for these three languages too. Let me open Spark documentation. Click on this Spark documentation, any version. Here you can see API documentation. API documentation is available for Scala, Java, Python, R language. So total 4 languages. So you can get quick start guide too. Here you can see programming quick start guide. Here they give some quick start implementation for RDD programming. See, Scala Python. Earlier they given Java, Scala, Python. Currently people are giving Scala, Python for more. Somewhere you will see Java also. Scala, Java, Python. So API documentation is available for 4 languages: Scala, Java, Python, R language. You can select any language. Whatever the language you want, you can select that language. So we are implementing PySpark, so you can click on Python. This is Python API. Let's understand. API means application programming. So you can find PySpark API. API stands for Application Programming Interface. Application Programming Interface means set of predefined predefined classes, set up predefined classes and functions. These API contains set up predefined classes and functions. By using these predefined classes and functions, we will build PySpark application. So this RDD programming nothing but Spark Core programming. So we call Spark Core programming, or RDD programming. So in RDD programming, we have transformations and actions. We have only transformations and actions. Transformation means converting RDD from one form to another form. Action means it is an operation. It will return results. Every action returns some result. Okay. Let's understand what are transformations. Transformation means converting RDD from one form to another form. Example, RDD has employee records. We want department number 10 records. So original RDD contain complete records. New RDD we want only department number 10 records. So we are transforming original RDD with our required operation. Some other requirement. We want to convert RDD, original RDD with new RDD with only female records. Another requirement we want only male records. Another requirement we want whose salary greater than 50,000. We want another requirement department 10 with female records. We want another requirement department 11 with male records. We want another requirement department number, no, we want to particular IT employee details. All department with a particular only IT employee details. See, we are converting RDD from one form to another form. Okay. So we have different transformations functions too. We have different transformations. We have map transformation. We have flatMap transformation. We have filter transformation. We have reduce transformation. We have group transformation. We have reduce by key transformation. We have group by key transformation. Group by key transformation. Okay. We have different transformations. We have many transformations. So learning RDD programming nothing but learning transformations, learning actions. So we can apply transformations on RDDs. We can apply transformations on RDDs. Every RDD returns, every transformation returns another RDD. Every transformation returns another RDD. RDDs are immutable. Immutable means not changeable, not changeable. So for every operation, it will return another RDD thing. Every transformation returns another RDD. So one more important about the transformations are lazily evaluated. Transformations are lazily evaluated. So when you apply transformation, immediately it will not create a new RDD. When transformations are executed, transformations are executed or evaluated when we apply action. Until action, just it will create one graph called lineage graph. We will discuss what is lineage graph later. So every transformation is a lazily evaluated. When we apply action, then only all dependent transformations will evaluate. Okay. So first one, transformation means converting RDD from one form to another form. We can apply transformations on RDD. When you apply transformation, it will return another RDD with result. I want to filter male records. Original RDD contain female and male records. New RDD contain only female records. On that second RDD, we applied department 11. So third RDD gets only department 11 records. So every transformation returns another RDD team. Every transformation is lazily evaluated. These transformations are evaluated when we apply action. Okay. So now let's understand actions. Action is an operation. It will return results. We can apply actions on RDD. So there are plenty of actions. We have count action. It will return number of records in a RDD. We have collect action. It will return all the rows of RDD. We have a take action. We have save as file. There are plenty of actions. So learning RDD programming means learning transformations, learning actions. So action means it's an operation. It will return results. We can apply actions on RDD. We have different actions: count, collect, take, save as file. There are plenty of actions available in the Spark RDD programming team. So these are very important RDD actions. Okay. Let's understand map transformation. Map transformation is a one-to-one transformation. Map transformation is a one-to-one transformation. It will take one record as an input. It will take one record as an input at a time. It will take one record as an input, one record as an input. Okay. It will take one record as an input and returns same record as a output. Same record as a output. Same record as a output. It will take one record as an input and it will return same record as a output with our custom logic applied on record, with our custom logic operations, with our custom logic operation applied on that record. So whatever the custom logic we write inside a map function, right? Map transformation, it will apply that custom operation and returns output. But exactly it will return one record. It will take one record, it will return one record. Middle it will apply our custom logic. Let's understand syntax of map transformation. Syntax of map transformation. So we call RDD dot map transformation. Here we write custom function lambda x colon and custom logic. Custom logic. We write custom logic. Whatever the custom logic we apply, right? So this applied on this record. This map function reads one record, passes that record to this custom function. Then we apply custom logic. It will return that record. Again, it will take one more record and applies custom logic. How many records are presented in RDD? Those many times this map function calls automatically. No need to call manually. No need to call manually map function on each record. Transformation means it will automatically take each record from RDD, passes to map function. Then inside this map function, we return custom logic. So whatever the custom logic we applied, right? It will apply that custom logic. Okay. So let's see one simple example. Let's see one simple example. I have a comment.txt file. I have comment.txt file. Let me take. I have comment.txt file. Let me show. Let me show here. Let me create a data directory. So in this data directory team, I am creating one comment file. Let me create a comment file. So I have a comment file with some data, Spark, Hive, Hadoop, Hive, Spark, Hive, Hadoop, Hive. Next one, Spark, Hadoop, Hive, Spark. Let's say we have these 4 records. Let me save this one in our data location. In this data location, I am saving this one as comment.txt file. So let's say I have a comment file. This is my data. So what I am doing, I am reading this comment file through my map transformation. So let me open Jupyter Notebook. Let me open Jupyter Notebook. Here, I said SparkContext is already created. So I want to read that file. So we are using read file. So first we are reading sc.text file, sc.text file, pass input of that file. File is presented in this location. So path input path, pass input path. In this location we have comment.txt file. Okay. So inside double quote, forward slash we have to pass 2 forward slashes. Otherwise, PySpark expects formatting character like slash and slash t, or you can use single backward slash. Then it will load this file, returns RDD. Then I am storing RDD in variable R1. Okay, next one. First I am printing for v in R1 dot collector, R1 dot collector colon print v. So before applying map transformation, I am displaying the data. Let me write that print statement. Print before map transformation. Before map transformation. Let me print this data. So we got the data, right? Yes or no? We got the data. So 4 records we got. I am applying map transformation. I am applying map transformation. Print map transformation. Map transformation. Okay. So here I am applying. So R1 dot map transformation lambda. I am writing lambda function lambda x colon x dot split based on space character. I am splitting based on space character. My input file contain each word with space character. Space character. So I am asking map transformation split each row based on space character. So here it will split this each row it will convert as a collection with multiple words. Each row it will convert as a collection. So every transformation returns what? Another RDD. Every transformation returns another RDD. Then I am using for v in R1 dot collect, v in R1 dot collect colon print v. Let's see output. Sorry, R2 dot collector. See, after transformation, each row is converted into collection. Yes or no? Each row is splitted into multiple words and converted as collection. Let's see here we have a space. Let's remove this space. Let's save. Because of space, it is given one more space as a character. Now let's execute. See, somewhere in another also we have space. Let's remove space. Once again execute. Right? We got output, right? So map transformation takes one record as an input and applies custom logic and returns as a one row as output. It taking one row as an input, it return as a one row as output with custom logic. Here we are applying custom logic is splitting each row into multiple words. All words are stored into a collection, returns that collection as a output. One row is returning as a collection form. Okay. So that's it for map transformation thing. So this is the example. Yep. In this session, let's understand flatMap transformation. FlatMap is a one to many transformation. one-to-many transformation. It takes one record as an input. It will take one record as an input and returns multiple records as a output. One or multiple records as a output type. So it is a one-to-many transformation. Syntax for flatMap. Syntax for flatMap. RDD dot flatMap, and here we write custom function, and custom logic. So based on the custom logic, it will return one or more row string. So for flatMap, we take what? RDD dot flatMap. So flatMap reads each row from RDD and passes to lambda function or custom function. Then X stores that custom first row. Then we apply our custom logic on first row. Then it will return one or more records. Next it will read second record and custom logic. It will return one or more records. Next it will read next record. Like this, it will pass each time one record as an input to custom function. Okay, that's why flatMap is a one-to-many transformation. Let's see it practically. Let's see. I have a data directory. So this is data directory. In this data directory, I have a comment file. This comment file contains 4 rows. Each row contains multiple words. Each word separated with space. Yes or no? Each word separated with some space. We are reading text file by using sc.textfile function. So we are passing text file. Then it will read that text file and converts as a RDD. R1 is a RDD. Then before flatMap transformation, we are displaying data of RDD. Then I am applying flatMap operation. R1 dot flatMap lambda x colon, I am returning x. I am reading x, I am returning x. So by default flatMap function splits your each row based on space character. So you will get list of words. Then I am storing that one in new RDD. Every transformation return another RDD, right? So here flatMap, flatMap splits each row as a multiple word string. Multiple words based on space. Space delimiter. Okay. So each row converted to multiple words. First row converted to 4 words. Second row converted to 4 words. Third row converted to 4 words. Fourth row converted to 4 words. Then it stores in new RDD. Then let's print after flatMap. So R2 dot collect. R2 RDD contain new data, right? Yes or no? Shift enter. So before flatMap, this is transformer data. Before flatMap, this is transformer data. After applying transformation, each word is splitted, not based on space. Each word is splitted. But we want to split what? Sorry, each character is splitted. Row is splitted, multiple words. Based on what? Based on character. So each character is splitted. But we want each word. Instead of each character, we want each word. Then you can use split function. You can use split function here. So flatMap x dot split based on delimiter is space. Based on delimiter is space. Shift enter. Let's observe. After flatMap, we got words. If you not give any delimiter, what will happen? Each character is splitted. So that's why we given what? Split based on space character. So it is splitted based on space character. Let's say print star into 30 times. Let's see. 1 minute. Yep. So understand, right? Let's take first example. Example 1. This is example 1. In this example, it is splitted each character. That's why I said it is a one to many transformation. It will take one row and returns multiple rows. It will take one row as input and returns multiple rows as output. Example 2. For same flatMap, example 2. We used to split character. We used to delimiter in split function. Then we got multiple words. Yes or no? Now let's understand one more transformation. Let's understand reduceByKey transformation team. ReduceByKey transformation. First it will perform grouping operation. First it will perform grouping operation. Next it will perform aggregation operation. Next it will perform aggregation operation. So first it will perform grouping operation. Next it will perform aggregation operation. Let's see syntax of reduceByKey. Syntax RDD dot reduceByKey. RDD dot reduceByKey. Here we write lambda. We will take two parameters. And we apply aggregation operation. This aggregation operation may be arithmetic addition, arithmetic subtraction, arithmetic multiplication, any logic thing. So here we write aggregation logic. So first, before calling this custom function, whatever the custom function we are writing, right? Before calling this custom function, reduceByKey, first it will read data of RDD and performs grouping operation. Grouping operation. Let's say we have data key value pair format. So first it will take reduceByKey takes input as key value pair. reduceByKey takes key value pair. Key value pair that is pair RDD. Pair RDD. It will take pair RDD as a input. Pair RDD as a input. It will take key value pairs based on key. Based on key. It will perform grouping operation. Based on key, it will perform grouping operation. Next, it will perform aggregation operation. Next, aggregation operation. Let's see practical implementation, team. So first we need to create a data in a pair RDD form. Let's set it. So first I am reading data. This is my data. So here I am writing pair reduceByKey transformation. So first one, before transformation. What is the data? So let me print this data. So this is the data thing. Then I want to convert this one into multiple words. Each word I want to convert as a key value pair. So I am doing converting key value pair. Converting key comma value pair. So we can write in this way. Two steps I will write. First one, r1 dot flatMap lambda x colon x dot split of space character. We give space character. This is one way. Next one. So it is returning R2, right? R2 equal to this one. Next one, team. R3 equal to R1 dot map. R1 dot map. Each word I want to convert to key value pair format. So lambda x colon. I am converting x comma 1. I am converting x comma 1. So it will convert each word like spark comma 1, hive comma 1, Hadoop comma 1. Like that it will print it. Let me print pair RDD. Printing pair RDD. Let's see. R3 dot collect. Then we are printing value. Let's execute this one. Let's see the pair RDD format. Oh, sorry. So flatMap R1 dot flatMap. Here we have to use R2 dot map. Let's see it. Pair RDD it is converted. Key is Spark. Value is 1. Key is Spark. Value is 1. key is high, value is 1. So it is converted pair RDD. So we can write multiple steps, team. We can write multiple steps. Okay. Or we can write a single step. Instead of writing multiple steps, we can write a single step. R1 dot flatMap. We are applying flatMap dot we can apply what? Map transformations. Once we got collection of words, once we got list of words, then on that object we are calling map, and we are passing each value. So this is R2. Then let's use this one, R2 dot collect. See, pair RDD. So simplified way. Here we are writing multiple steps. Here we write a single step. Okay. Once we got a key value pair, then we are applying reduce by operation. Reduce by key operation. Let's see how we are applying reduce by key. R3 equal to reduce by, sorry, R2 dot reduce by key. Then here we are passing lambda function x comma y colon x plus y. Then I am printing print word count result. Then use this one. Use this logic to print. So R3 dot collect. Let's observe each word repeated, how many times it will display. High word repeated 5 times, Hadoop word repeated 6 times, Spark word repeated 5 times. So what is happening here? In reduce by key, what is happened? First it will perform thing. Before performing this custom logic, it will perform grouping operation. First it will perform grouping operation. Observe, in grouping operation what will happen? It will take Spark keyword. So this is one Spark keyword. Okay. So key, this is a key, and value is what? Value is a list. So first one it will take 1. In this list it will take 1. Next it will take next word Spark. Next word is also word Spark. Already key is available. If key is available, it will append a value to list. Next it will take next keyword, key value pair. There is no key presented in here. Then it will create one more object. So with this key value pair, key is a high, value is 1. Next word Hadoop. There is no key value pair presented right here. Then it will create a new key value pair. So Hadoop, and value is inside a list, value is 1. Next one, it will take another keyword Hadoop. Hadoop key already presented, then it will append value to value list. Next one, it will take a hive. Hive key already available, it will append value to value list. Next it will find the Spark. Spark key already available, it will append value to value list. Next one team, hive. Hive key already available. It will append value to value list. Next one, we have 3 Hadoop keys. Hadoop keys already available. It will append values. Next one, Hive. Hive key already available. It will append value to value list. Next one, Spark. Spark key already available. It will append value to value list. Next one, Hadoop. Hadoop key already available. So it will add value to value list. Next one, Hive. Hive key already available. It will append value to value list. Next one, Spark key. Spark key already available. It will append value to value list. So first, before performing this logic, in this way it will prepare grouping operation table. Then it will pass key value pair. Then it will first key value pair it will take. Then from this it will take value list. This value list pass to this custom function. So first 2 values 1, 1 is passed to x, y. So 1 plus 1, 2. 2 is going to store in x. Third value 1 is passed to y. 2 plus 1, 3 is going to store in x. Fourth value 1 is passed to y. 3 plus 1, 4. 4 is going to store in x. Fifth value 1 is passed to y. 4 plus 1, 5. So we got Spark 5 times. Next iteration it will take another key value pair. So next key is Hive and it will pass this entire value list to this lambda function. Hive is repeated 5 times. Next one, Hadoop key value pair. So Hadoop key value pair is 6 times. In this way it will find the thing. So reduce by key, first it will perform grouping operation. Next it will perform aggregation operation. In aggregation, for each key we have a list of values, right? That list of values passed to custom functionality. So first 2 values are passed to first argument and second argument. Result of aggregation logic stored into first argument and next arguments passed to second argument. In this way reduce by key happens thing. So we return multiple steps, right? Instead of this we can use single step for performing aggregation operation. So we can perform single step. This is another step too. So R2 equal to R1 dot flatMap. We are getting multiple words. We are converting multiple words as a key value pair. And once we got key value pair, we are applying reduce by key. And here we are writing lambda x colon x plus y. Sorry, x comma y colon x plus y. Then display logic. Single statement we are writing. Shift enter. Stating in a single logic we are printing. Yes or no? So one statement, loading file. Once we load file, then apply this logic. In a single statement, we are writing entire logic to perform word count operation. Okay. So let me copy this entire program thing. Reduce by key transformation. So first writing example 1. Step 1, loading file. So step 1, loading file, and next one, step 2, splitting. splitting each row into multiple words, each row into multiple words. Then step 3, converting key value bytes, So this one we are using, converting key value bytes. And instead of step 3, step 2 and step 4, step 3, instead of step 2 and step 3, we are writing single statement. Right? So next step 4, performing reduce by key. This is reduce by key. So instead of step 2, comma step 3 and step 4, instead of step 2, step 3, step 4, okay, we are writing single statement. This is single statement. Simple step. Okay. So that's it for reduce by key transformation. Let's start him. Today we are going to discuss Spark architecture. Before going to discuss Spark architecture, first, what is Spark? So Spark is a big data processing framework, right? Spark is a big data processing framework. It can process any file system data. It can process any file system data. So we can implement Spark using Spark using Java language, Scala language, and we can implement by using Python language, and we can implement using R language. Yes, sir. So we can implement by using 4 languages. So Spark is a big data processing framework. Next one, how do we execute programs on Spark cluster? How do we execute Spark programs or Spark applications? How do we execute Spark applications? How do we execute the Spark applications? How do we execute the Spark applications? So first one, we have two types of client machines. Two ways. One is interactive clients. Yes or no? In two ways. In two ways, team. Two ways. They are first one interactive clients. Interactive clients. So interactive clients we have one Spark-cell. Spark-cell. We use Spark Scala applications. Spark and Scala applications we can execute in Spark-cell. Second one we use PySpark cell. PySpark cell, or we use notebooks. We use notebooks. So this is for PySpark. This is for Python with a Spark. Python with a Spark. This is for Spark and Scala. Spark and Scala. So this PySpark cell or notebook we use for PySpark. So first one interactive cell. We can start Spark-cell. We can write Spark programs, or we can use PySpark cell. We can write Spark programs. In Spark-cell, we write Scala programs, Spark and Scala programs. PySpark cell or notebooks, we will write PySpark applications. Second one is script applications or batch applications. We have script applications or batch applications. Script applications or batch applications. We submit using Spark-submit. Spark-submit. So first one interactive cell. So second one Spark-submit by using Spark-submit utility. So once we develop applications, once we develop applications, we will submit using Spark-submit. Spark-submit utility. Once a complete application is developed, we can submit Spark applications using submit utility. Let's say this is our developer mission or client mission. So from client mission, we submit our Spark application. Once a Spark application is completed, let's say this is our Spark application, Spark app. Once a Spark application is completed, we submit the Spark application to cluster. We submit our Spark application to cluster. So what we will do here, we will create a packaging. We will create a package and we will submit the Spark application to cluster. So packaged Spark application. Packaged Spark application. we can submit using Spark-submit utility. Spark-submit utility. By using Spark-submit utility, we submit the Spark applications to cluster. Once a complete application is developed, once application is developed, we submit the Spark application to cluster using Spark-submit utility. How does Spark executes our applications on a cluster? How does Spark executes? How does Spark executes our applications? Our applications are programs. Our applications are programs on cluster. So very important thing. How Spark executes our applications on cluster. So Spark cluster uses master-slave architecture. Spark cluster uses master-slave architecture. Let's see diagram team. Let's see diagram. So here we have master-slave architecture. We have master and n number of slave missions. So this is a master mission, and this is slave mission. Slave mission or worker mission too. Slave mission or worker mission. So we may have multiple slave missions, one or two masters and multiple slave missions. In master mission, it will start driver. In master mission, it will start a driver. In master mission, it will start a driver. And in worker missions, it will start executors. In worker missions, it will start executors. So it will start executor in worker mission team. Then driver start tasks on executor missions. Executor missions. So driver starts tasks on executor missions. So we have master slave architecture. Spark is a master slave architecture. Let's say we have multiple missions, multiple tasks. Let's say take one more time. Let's say this is our client mission. From client mission, we have multiple applications. So this is our client mission. So here we have developed multiple applications, application 1 and application 2. Application 1 and application 2. So we are submitting this application to cluster. App 1 and app 2. So client is submitting multiple applications to multiple applications in cluster size. In cluster size, so this is our cluster. For each application, it will create separate driver. For each application, it will create a separate driver. It will create a separate driver. So here it is creating two applications we are submitting, right? So two drivers it will create. Driver, driver, and driver. Each driver runs on master machine. Each driver runs on different master machines or single master. So we have different drivers. Each driver requires multiple executors. Multiple executors still. Each driver requires multiple executors. Multiple executors. So we have, for first application, it is started 3 executors. Let's say second application, it is started 3 executors. For second application also, it is started 3 executors. So this driver using these executors, and this driver using these executors. So from client mission, we can submit n number of applications to. For each application in cluster, it will create separate driver. Each driver, it will create, for each driver, it will create multiple executors. So it will execute tasks on executor missions. Now let's understand how does the Spark executes our programs on a cluster. How does Spark executes our programs on a cluster, right? So we submit our applications to Spark cluster. So in how many ways we will submit application to Spark cluster team? So first one here, we will submit the Spark applications. We will submit Spark applications. We will submit Spark applications to cluster in 2 ways. We will submit Spark applications to cluster in 2 ways. One, client mode, and second one, we submit the Spark applications in cluster mode. We submit the Spark applications in client mode and cluster mode. So what is client mode and what is cluster mode? Let's understand client mode. Client mode. Client mode. So client mode. So before going to understand client mode or cluster mode, so who is responsible to process our application? So first one, driver is responsible for whole application. Whole application team. In a driver nothing but creating Spark context. SparkContext or creating SparkContext called driver creation. So this is until 1.x from until Spark 1.x from Spark 2.x creating Spark session driver program creation, nothing but creating SparkContext or creating Spark session. In every Spark application we create the SparkContext or Spark session, right? So until 2.x, sorry, from 2.x, from Spark 2.x we use SparkContext. So SparkContext until Spark 1.x, SparkContext is the starting point of any Spark application. From Spark 2.x, Spark session is the starting point of any Spark application. So creating driver program, nothing but creating driver program is nothing but creating SparkContext or Spark session. Whenever we submit a Spark application to cluster, it will create a driver program. Driver program means creating SparkContext or creating Spark session. So driver program is responsible for whole application. So if anything goes wrong, in driver application. If anything goes wrong in driver application, then application state is gone. Then application state is gone. If anything happen in a driver application, then application state is gone. Okay, so now let's understand client mode and cluster mode. We will submit the Spark applications we will submit the Spark application to cluster in two ways: client mode and cluster mode. So what is client mode and what is cluster mode? So client mode means driver creates on a client mission. Driver creates on a client mission, and driver creates on a client mission, and executors creates on a cluster missions. Executors creates on a cluster. Example, let's see it. Let's see diagrammatically. Client mode. So we have a client mission. Here we are running Spark application in client mode. So we are submitting Spark application in client mode. While using Spark-submit mode, we are using client. Whenever we use client mode, it will create a driver application in client. It will start a driver in client mission. Then executors starts on cluster. depends upon the data, it will start number of executors. So this client program communicates with executors. Our driver program communicates with executors. Understand, right? In a client mode, driver program creates in a client mission, and executors creates in a cluster. Executors starts in a cluster. So in client mode, in this mode, client mission should up and run. Client mission should up and run until program completion. Until program completion. Yes or no? Because driver is responsible for whole application. So if anything goes wrong in driver application, we lose entire state of application. Yes or no? Driver is running in client mission. So client mission has to exist until program completion. Otherwise, we lose application state. We lose application state. So if you run application in client mode, our client mission has to run up and run until driver program or application has to finish. Otherwise, we lose application state. So most of the time, we never use this client mode thing. We never use client mode. Rare cases we use client mode. When we use client mode means whenever you want to debug the application. If you want to debug the application, we use client mode, not all the time. So this is used only in debugging purpose. Important note. This is not used. This is not used for production. This is not used for production. This is used in development and for debugging purpose. Not for production team. And other mode we have cluster mode. Other mode we have cluster mode. What is cluster mode? In cluster mode, both driver and executors run on cluster. Both driver and executor runs on cluster. Let me take diagram. So this is our client mission. While writing Spark submit, in client mission, while writing Spark submit, we use mode equal to cluster Spark submit. So here we specify mode equal to what? Cluster. When we say cluster mode, so in a cluster, it will start a driver program. In a cluster, it will start driver and it will start number of executors. So both driver and executor starts on both driver and executors starts on cluster mission. So this is cluster mission. Cluster. Cluster means collection of missions. So in this case, client mission, just we use Spark submit command. Then driver is started in client mission. Then this mission may not up and run until program completion. So this driver program will taken care for whole application process. So this driver starts in master mission of cluster. Okay, this is cluster mode thing. This is cluster mode. So in this case, once request is submitted to once request is submitted to cluster, client may not be run. Client may or may not be up and run. It is not mandatory thing. So cluster will taken care. Cluster will taken care to continuation of processing, because driver is started in a cluster master mission. So that driver is responsible for whole application process. So we run our application in cluster mode. Driver program is started in cluster. In cluster, it will start in master mission. Okay. Continue, team. Who controls the cluster? Who controls the cluster? Who controls the cluster, or how Spark application gets the resources for the driver and executors? How Spark gets the resources? How Spark gets the resources for the driver and executors? Important point to think. Spark applications we can run on 3 environments, 3 cluster environments, 3 cluster environments. One standalone master slave architecture. standalone master slave architecture, and second one yarn architecture, and third one mesos architecture, and fourth also implementation started, not yet completed, Kubernetes. So fourth is in R&D, not completed team, it is in R&D phase. So three are important: standalone, master slave architecture, yarn architecture, and mesos architecture. Let's diagrammatically discuss. Once we develop applications, so this is our client machine. So here we have a Spark application. Spark application. Once we develop a Spark application team, we submit this Spark applications using Spark submit utility. We submit the Spark application using Spark submit utility, Spark-submit. Here we use two modes. Yes or no? One is client mode and another one is cluster mode. Yes or no? We use two modes. We submit our Spark applications either client mode or cluster mode. Whether it may be client mode or cluster mode, we submit our Spark application to three environments. One is Spark master, Spark standalone, master slave architecture. So we have one or more masters and multiple worker missions or slave missions. Team. We have one or more multiple worker missions or slave missions. So master and slaves. Like this, we have three environments. Let's say this is Spark standalone master slave architecture. This one is yarn architecture. So this one is mesos architecture. So we can submit our Spark application using Spark submit. We can submit to either Spark standalone architecture or yarn architecture or mesos architecture team. We can submit our Spark application to any of these architectures. So after completing Spark application, we can submit the Spark applications to any of these architectures. Okay. So here mostly used one is yarn architecture. So important to note, yarn is mostly used architecture. used architecture to run Spark applications team. Yarn is the most used architecture to run Spark applications. Now let's understand how we are going to submit Spark applications to Yarn architecture. How we are going to submit Spark applications to Yarn architecture. How we know how to submit. So let's understand who controls the cluster in Yarn architecture, how Spark gets the resources for the driver and executors. Let's understand Yarn architecture. Yarn architecture is a Hadoop architecture. Yarn is Hadoop architecture. So in Hadoop, we submit our Spark applications in two modes. For Yarn also we submit Spark applications in client mode and Spark applications in cluster mode. Okay, let's see diagrammatically. Spark applications to Yarn. Client mode and cluster mode. Client mode and cluster mode. Let's see team. We have Spark application in a client mission. So this is our client mission. Here we submitted Spark application to cluster. So here we have cluster. So this is our cluster. Same way in cluster mode. So in client mode, driver starts in where? Driver starts in client mission. In client mode, driver starts in client mission. So this is Yarn cluster. In Yarn cluster, first one, there is a component called resource manager. There is a component called resource manager team. So first important component, resource manager. So first driver request goes to resource manager. It may be SparkContext, it may be Spark session. Driver sends request to resource manager. Then resource manager creates one more mission called, we'll see. Resource manager creates one more mission called application master. In Yarn architecture, there is one more important component called application master. It will create application master. application master. So resource manager instantiate application master. Resource manager instantiate application master. Then what this application master do? It will ask resource manager to create resources. I want to so many resources. It depends upon the data size, depends upon the number of tasks. It will ask resources. Then it will create resources. It will create resources. So application master will ask, I want to 3 containers or 4 containers or 5 containers. So application master. So in client mode or cluster mode, what will happen? Here resource manager creates application master. Then this application master asks resource manager to create containers means mission string. How many containers we want? Container nothing but JVM. So it will ask, depends upon the data size, depends upon the number of tasks. It will ask containers. Once this resource manager takes request and creates required containers. Let's say it is created 3 containers. Resource manager created 3 containers. Then application master starts executors. Application master starts executors in this missions. Executors in this mission string. It will start executor. It will start executor. It will start executor on this mission. Okay. So in this way, similar happens in YARN cluster also, little different. Then once it is completed, then now first driver is requested resource manager. Then resource manager created application master, and application master asks to create containers. Once containers are created, application master starts executors. Okay. Once executor is started, now driver communicates with this executor string. Driver communicates with this executor and sends tasks. Driver communicates with executors and sends tasks. Once these executors are created, then driver can communicate with executors. But here in cluster mode, we write only Spark submit here. Spark-submit. Once we write to submit, here also we return Spark submit. Spark hyphen submit. But here driver program is created in client machine. Yes or no? But here driver program is going to create in this machine. Let me take more image, bigger image. So it will start driver in YARN cluster. So let's first understand what will happen. So first request comes to resource manager. Resource manager. Resource manager. Request comes to resource manager. This Spark submit request comes to resource manager. Resource manager starts what? Resource manager starts application master. Resource manager starts application master. So resource manager starts a application master. Inside application master, it will create a driver. Inside application master, it will create a driver team. It will create a driver. Okay, application master requests resource manager to create resources. Then here it will create containers. First it will create containers. How many containers it want? It will create those many containers. In each container, so resource manager creates containers. Then once it is created, right, application master starts executors on each container. Executor. It will start executor on this mission and second mission and third mission. Once executors are created, driver sends tasks to these executor missions. It will send tasks. It will sends tasks to you. So in client mode, driver object is created in client mission. In cluster mode, driver object is going to create in master mission. Which master mission? Application master mission. Okay, so this is client mode and cluster mode. So understand right team? Spark is a master slave architecture. We understand Spark is a master slave architecture. We have masters and slaves. In master mission, driver object is going to create, And slaves missions what? Slaves mission executors are going to create. So driver is a main important central coordinator thing. Central coordinator that can communicate with many workers. So these missions we call it as worker missions. Worker 1, worker 2, worker 3. So it will create multiple workers. So these are worker missions. These are workers. Workers. So it communicates with worker missions. So driver is the main important component. So driver and each executor, it runs on separate JVM. I said right, container means JVM. Okay, so driver is main important component. In a driver, it will start what? Until driver is nothing but creating Spark context or creating Spark session. So this driver program converts instructions of user into multiple tasks. Let's say we have map transformation, flatMap transformation, reduce transformation, filter transformation, count operation, collect operation, take operation, etc. These are different tasks. These are different tasks. So driver program converts the user program into multiple tasks and runs on the executor machines. Next important component, executor. So executors are responsible to run your programs. In a ARN architecture, executor runs in node manager mission team. Executor runs on node manager mission. So each individual task is run by executor and finally updates status of each task to, it will update status of each task to driver program. It may be cluster mode, it may be client mode. Executors updates the status of each task to driver program. Once a program is executor completed a task, it will send a response back to driver application. So these are important steps in application flow. Any standalone application starts instantiating Spark context until Spark 1.x. or Spark session from Spark 2.x. Spark 2.x. So it will create what? Either Spark session instance or Spark context instance. Next one, once a Spark instance is created, then we call that instance is a driver program. This driver program send a request to resource manager. Resource manager, I want to resources to run Spark application. Resource manager creates application master. Application master ask resource manager to create containers. Then once it will create containers means JVMs on multiple missions. Then once it is created container, application master starts executors on container missions. Then it will send that information to driver. Then driver executes tasks on executor mission stream. The cluster manager launches executors. Then the driver program runs on the user application, depends upon the actions of transformations over the RDD and sends that task to executor missions. Executors are responsible to execute the task, transformations and actions, and finally save the results. If any worker crashes, means this executor mission crashes, it will start executor worker mission. It will start the same executor on another mission of cluster. So cluster manager will take care. If any worker mission down, right? If any worker mission fail, so this resource manager will take care to start same executor on another mission in a cluster. As a Spark developer, we least bother about whether worker mission is running or not. Okay. So if any worker crashes, its tasks will sent on different executor and continuous processing. So we have a SparkContext.stop option. So it will stop program execution. Once a complete program is completed, once a complete application is completed, inside a driver, we have an option executor.stop. Sorry, SparkContext.stop. It will stop entire application flow. So these are the 7 important steps happen in any Spark application flow team. Understand, right? Understand, right? Spark architecture. So once we develop a Spark application, we submit the Spark application to cluster. So it will start a driver and it will start executors. Driver starts in master mission. Executor starts in slave missions. If you run multiple applications, multiple driver programs and multiple executors creates. For each driver, it will create multiple executors. Right? So in client mode, driver starts in client mission. Executors starts in cluster. In cluster mode, drivers and executor starts in cluster. So we see how we are going to submit Spark applications. We are going to submit Spark applications in 3 environments: Spark standalone master slave, Yarn architecture, Mesos architecture. Apache people implementing, submitting Spark application to Kubernetes, but it is in R&D phase. Next one team. So we understand in submitting Spark applications in client mode in Yarn cluster, cluster mode in Yarn architecture. So that's it for complete Spark architecture class team. Okay. So we understand what is client mode. In Spark architecture, we understand what is client mode, what is cluster mode. Let's understand local mode. What is local mode? We set in this way, right? So configuration equal to SparkConf, and we set conf dot set master. Conf dot set master. We will set local of star. Yes or no? We set conf dot master, then conf dot set app name, set application name, and we set application name app1. Then we pass this configuration to SparkContext. SparkContext, yes or no? Conf equal to conf. So in this way we set. Here let's understand. Here it will start local mode team. Here it will start local mode. So when we start this one, whenever we execute on command prompt PySpark cell, it is started Spark, and it will open PySpark cell. Here we will write these commands. Yes or no? Here we write these cells are in our PyCharm ID. In PyCharm ID also we will write this kind of statement for creating Spark configuration object. Spark configuration object as well as SparkContext object. For SparkContext object, we will pass Spark configuration object. Then we will continue rest of the program. Yes or no? So once we submit this application, it will run local master. When we go this kind of situation, let's see it diagrammatically. So this is my developer mission. This is my developer mission. This is our developer mission. Developer mission. This developer, before going to deploy this application into cluster, before going to deploy application into server, it may be Spark standalone server, it may be Yarn master, Yarn cluster, it may be Mesos cluster. Before going to deploy this application, developer test the application in local system, right? Yes or no? In our local system, developer local system, they have operating system. Yes or no? Operating system. Operating system may be Windows operating system. Operating system may be Linux operating system. It may be Windows or it may be Linux operating system. Developer operating system may be any operating system. Okay, first one. On this operating system, they will install Java. In developer mission, we will install Java. Yes or no? Simply we can say JDK. On top of this JDK, we will install language. If you want to Spark, Scala, we install Scala. If you want Python, we install PySpark. If you want PySpark, we install Python. Then on top of this one, we will install Spark. We will install Spark. Yes or no? Then we will write a Spark application. Yes or no? Here we are writing Spark application. And once we write a Spark application, we will run this Spark application in local system only. Yes or no? We will run this Spark application in local machine. Before deploying this application into Spark standalone master or Yarn master or Mesos master, developer runs this application in local machine. So in this local machine, it uses local mode. So it uses what? Here it uses local mode. Here it uses local mode. That's why we mentioned set master equal to local of star. What is this star? We are going to discuss later. So we are assigning local master. Where is local master? We have this Spark library, right? This Spark application uses this local library. This is local master to run this Spark application. Okay, so that's why we are saying this is local mode. Understand, right? What is local mode? In Spark architecture, what is local mode? You understand, right, team? Team, did you understand what is local mode in Spark architecture? So in developer mission, if you run Spark application, nothing but we are running here Spark application, right? Yes or no? So this is Spark application. If you open PyCharm, we are going to run in a same mission. So it uses local mission. It uses what? Local mode. Local mode. Okay. So in this local mode, so drivers and executors started in same mission team. Driver and executors started in same mission. Driver and executors started in same mission. Executor or executors. So we don't know how many executors are going to start. It may start one executor or it may start multiple executors. Depends upon the data size, depends upon the partitions. It will start multiple executors in this mission team. So both the driver and executor starts in same mission. So this mission we call master and slave mission. It uses Spark library to execute Spark applications. Okay. Understand, right? What is local mode? So we already understand what is client mode. We already understand what is cluster mode. Now we understand local mode. Local mode we use only for running Spark applications in developer mission. Developer mission. Okay. So in local mode, both driver and executor or executors starts in developer mission team. Okay. So that's it for local mode. Let's start in. In this session, we are going to discuss Spark Web UI. What is Spark Web UI? For any Spark application, Spark application, Spark creates one web user interface. Spark creates one web user interface. Web user interface team. For any Spark application, Spark creates one web interface. If we run multiple Spark applications, Spark creates separate web user interface. Web user interface. First Spark application. Web user interface is localhost :4040. Second Spark application. Web user interface is 4041. Like this, for every application it will create a separate port number. Whenever we start a Spark application, first it will check 4040 port number. If it is not available, then Spark creates 4041. If it is not available, it will create 4042. Like this, if you start n number of applications, it will start n number of port number string. So first application, it will start from 4040. Let me open Spark application. So let's start PySpark. Let's start PySpark. So I'm entering into workspace, Spark Core. Let me start command prompt. When I type PySpark, it will start one web user interface. It will start one web user interface. So we are opening Python 3, but along with this one, it will start one web user interface. Web user interface is localhost colon 4040. Let's see. 1 minute. Let's refresh. Yeah. So this is our web user interface. So PySpark cell. Let me start one more Spark application. Let's say I'm closing this one. Let me leave. Let me close. Let me close this one. Let me remove this one. Entry of Jupyter configuration team. Enable configuration. Let's say PySpark configuration. So I'm removing this PySpark configuration team. Similar way, I'm removing this one. Click on OK. Click on OK. Click on close. Now I'm opening command prompt. Through this command prompt, I'm executing PySpark command. It will start a PySpark cells. Yes or no? It will start PySpark cell. Let's open browser. See, it will open localhost colon 4040. First Spark application. Next one, if you observe here, you see port number also. Spark Web UI port number. Yep, it is not showing here. So we've opened Spark Web User Interface, right? Similar way, I'm starting one more PySpark cell. So first it will try 4040. If 4040 already opened, then it is started with 4041. 4040 already bind, so attempting to connect to 4041. Let's open browser. Localhost colon 4041. Let's open another command prompt. Type PySpark. So first it will try 4040. Next it will try 4041. Next it will try 4042. 4042 is not available. Then it will start PySpark in 4042. Let's open browser. Again open localhost colon 4042. Yes or no? Let's open another command prompt. Let's again start PySpark cell. First it will try 4040. It is already binding. 4041 already bind, 4042 already bind. Then it will start 4043. Okay, let's open another prompt. Localhost colon 404043. Yes or no? So for every Spark application, it will create a separate web user interface. First important point is, for every Spark application, it will create a separate web user interface. What is the main advantage of this Spark web user interface? Advantage of Spark web user interface. Web user interface. What is the advantage of Spark web user interface? First advantage is, we can see what is happening inside Spark application. What is happening inside Spark application? First important point. So let's go here. Here, if you see jobs, whenever you start any job, it will, whenever you write any PySpark application contain multiple jobs. Each job contain multiple tasks. So that complete information we can see here, whether job is completed or not. Inside job, we have multiple tasks, whether tasks are completed or not. How many cores are allocated? How many processors are allocated? Sorry, how many cores and processors are same? How much RAM is allocated? How many executors are started? Complete information we can see in web user interface. Web user interface. So complete Spark application information we can see in web user interface. In Spark application, is there any stages? How many stages are completed? If there is any stage failed, what is the reason it is failed? Did we save any RDD, or did we persist any RDD? We can see persisted RDD information here. What is the Spark environment? We can see complete Spark environment. Executor information. How many executors are presented in our system? Total number of cores in my machine is 4. How many are allocated? How many are available? Executor name, driver program. Whenever we execute PySpark, it will create a driver. It will create a driver team. So complete information here we can see. And other, see SQL queries. If you run SQL queries, it will display SQL queries information. This is our Spark application. If you give any application name, we can see that application name here. Okay. Let's see. Let me take any one machine thing. So let me load some file. Let's say I want to create R1 RDD. So sc dot text, sorry, sc dot parallelize and pass local collection 10, 20, 30, 40, 50. So I'm close this collection. So I created one RDD, then R1 dot count. I'm executing R1 dot count. Before executing count, let's observe, remove all other. Okay, close all other console. Let's see it. So here I'm executing count. Before that, let's refresh. there are no jobs is executed. There are no jobs is created because we loaded file, we created RDD. This is one loading operation. When you load, it will not execute immediately. When RDD is going to create, whenever we apply any action, every action is one job. Let's execute command name count. So count is total 5 rows. Let's go refresh. So it is created one count job. Click on this count job. So click on this count job. So count, whenever we click on count job, this count job contains stages. So these are different stages. Are you observing? Okay, let's go to jobs. Here, this is count job. Here you can see DAG visualization tip. So parallelize function, by use parallelize function, we created RDD. We have only stage 0. Go to stages, go to storage. We did not persisted any RDD. Click on executors. How many executors are available? 4 executors. Means 4 cores are available in our system. Each core is one executor. Okay. There are no SQL statements. So important point to think, when you write any Spark application, inside Spark application, we will write what? Loading file, performing transformations, and performing actions. Yes or no? So once we do all these operations, we will submit the Spark application to Spark cluster. Here we are submitting local. Once we submit the Spark application to master, what will happen? It will start a Spark applications. Along with it will start Spark web user interface. For every Spark application, it will create separate web user interface. For every Spark application, it will create separate web user interface. First one. Second one, team. Second one, if you start 4 applications, it will start 4 web user interface. Every web interface contains sequence of jobs or multiple jobs of Spark application. Each job contains multiple tasks or multiple stages. And for each application, it will allocate multiple executors to process the data. Yes or no? So that complete information we can see in Spark web application. Okay. So we started 4 PySpark cells. For each cell, it is created separate web user interface. Yes or no? So like this, in real application development, multiple applications may running in Spark cluster. Each application information you want to know, you can open Spark web user interface. Here we are running in same mission. That's why we are using localhost. So if you submit a Spark application to cluster, we need cluster IP address :4040. First application. Second application 4041. Third application 4042. Like this, n number of applications, n number of ports. Okay. Understand, right? What is the purpose of a Spark web UI? For every Spark application, separate web user interface is presented. Through web user interface, we can see what are the jobs are created for that Spark application, what are the tasks are created. Complete diagrammatically we can see. We can call that the diagram is DAG, direct acyclic graph, or lineage graph. We can call lineage graph. We can discuss what is lineage graph in next sessions. Okay, coming sessions we are going to discuss what is lineage graph, how lineage graph is going to create, who is going to execute a lineage graph. These things we are going to discuss in next coming classes too. But in this session we are discussing what is Spark web user interface. Okay, understand, right? Every Spark application contain jobs. Every job contain number of stages. So total duration it is taken 3 seconds. To complete that task, it is taken just 3 seconds. Okay. Let's start it. In this session, we are going to discuss how to allocate number of cores to application. How to allocate number of cores to application. So we discussed SparkConf. Remember, SparkConf. SparkConf is a predefined class. SparkConf is a predefined class. Is a predefined class. Predefined class presented in PySpark package. Presented in PySpark package. PySpark package. Okay. So here this class can be used to provide configuration to Spark application. Is used to provide configuration to Spark application. Configuration to Spark application. It is a predefined class. This class can be used to provide configuration to Spark application. So by using this class, we can set different parameters. Use it to set different parameters. Different parameters as a key value pair, as a key comma value pair. Key comma value pair formatting. So this class contain get all function. This class contain get all function. First one, get all function to read what are different parameters are set. What are different parameters are set to Spark application. So by using get all function, we can read all. Or set function. Set function can be used to set can be used to set parameters, set different configurations as a key value pair. Key value pair. Or instead of set function, Spark latest version given, Spark latest versions given for each key they given separate function. For each key they given separate function. Separate function thing. Separate functions. Example, let's say let's set it. I want to set a master. We use first we create a spark conf. Okay, spark conf equal to spark conf. Then we use conf dot set. Here we use master. Master is a key, comma, value is master value, local. Of here we set a value. So this is master's value. Or we can use, instead of this set function, we can use conf dot set master is a predefined function. For every key, for every key of set function, they given a separate function type, separate function with a set key name, set master. You can directly set a master. First, let's see what are different keys are presented. Yes or no? So if you want to know what are different keys are presented, we use get all function. Get all function. Let me open Jupyter Notebook team. Go to workspace. Open command prompt. Type Jupyter space notebook. Parallelly, I'm going to start PyCharm IDE. Okay, here I'm creating new Python 3. So first one, important to note team. Important to note. In Jupyter Notebook, in Jupyter Notebook, or PySpark cell, both SparkConf, comma, SparkContext, and Spark session is already created. Spark session is already created. Spark session is already created. If it is a PyCharm or any IDE, we have to create manually. We have to create. Okay. So both the ways I am going to show. So first I am going to show Jupyter Notebook team. First, let's print conf. Next one, print type of conf. Next one team, print SparkContext. Print Spark session. So print SC is a context name and SC, type of SC. Type is a function, it will display type of variable. So print Spark and print type of Spark. Shift enter. So importantly, in Jupyter Notebook, so configuration is not created, but SC in SC, while creating SC object, they created configuration parameters team. So we can get configuration parameters through SC context. Okay. So let me open one more page. Let's see. Spark documentation. Let's click on Spark documentation. Go to API documentation, Python. Here we have different Spark packages, PySpark package. Here we have SparkContext. Click on SparkContext and SparkConf. Let me click on SparkContext. So these are different functions team. So get all is a function. Get all is a function. So to get all list of key value pair parameters. So to set key value pair and to set application name, to set master name. So it is presented in Spark configuration class. Okay, Spark configuration class. Okay, let's see it. So we can set using Jupyter Notebook. Let me set conf equal to Spark conf. Print conf dot get all function. So we have to import Spark configuration class. So from PySpark, sorry team, I think we started this tab using Jupyter Notebook command. Let me open. Command is PySpark. Yep. Let's open new Python 3. So now print SC. Sorry, conf. Print SC. Print SC. Okay. So print Spark. Okay. Now let's come. So conf equal to SparkConf. So print conf dot get all. So these are different parameters. Print Spark dot get all. So if you want to set any parameters, okay. So print star into 30 times. Now I'm setting print. Sorry, not print. Conf dot set. Here we are setting master. Spark dot master. Master name we are setting local. local of star. So next one, in this way we can set R, we can set what? R, we can set conf dot tab space string. Tab space, click on tab space, it will display list of functions. Set master. Master name we are setting local of star. Here local of star means we are setting all cores. How to set a number of cores? So this is our main topic. So by using SparkContext, we are setting what? Number of cores string. Number of cores means we are setting all cores of our system. My system has 4-core processor. So I am assigning 4 cores to this application. First, let's set parameters. Conf dot set app name. App name I am setting assigning cores. Assigning cores. So now once again I am print conf dot get all function. Previously master is local star, same we are setting local, instead of star I am setting 2 cores. Okay, next one, spark dot application name, it is shown PySpark cell, but we are setting assigning cores, so it will display assigning cores. Let's execute it. See, spark dot app name assigning cores. Spark master is local of 2. So we are changing parameters, right? Let me copy this one. Let me copy this one. So in Jupyter notebook, in Jupyter notebook, we written in this way. So output is this one. So understand, right? How can we change the parameters? Here by using Spark master function, by using Spark master set master function, by using set master function, we will set master like local master or local master or Spark standalone master, Spark standalone master, Spark standalone, Spark standalone master or yarn master or Mesos master. In this application we set local master. Along with this one, along with master, we will set number of cores. So here we are setting static value static value. Instead of static value, we can set dynamic value. We can set a dynamic value type. I will explain how to set a dynamic value. Okay. So each key value pair we can set a dynamic also by reading key value pair. Okay. So let me explain. Here local of star means assigning all processors, assigning all processors. Here local of 2 means local of 2 means assigning instead of processors cores of a processor, assigning two cores of a processor. Okay. So nowadays we are getting multi-core processor. We are getting multi-core processor. My system is a i7 processor, and i7 processor, this processor contain 4 cores. Nowadays we are getting even i3 processor also. We can get 8-core processor, 16-core processor, 32-core processor. So each core can process millions of instructions in a second. Each core can process millions of instructions in a second. So powerful processors we are seeing. So instead of wasting our processors, we can set the number of cores to our application, so that application process very faster. We are utilizing cores of processor. Each core can process millions of instructions in a second. Very powerful processors. We are assigning number of cores to application, so that it will improve your Spark application very faster. Processing is very faster. Okay. So here star means what? All cores. Instead of all cores, you can specify 2 cores or 3 cores or 4 cores, 8 cores or 16 cores. Depends upon your number of cores presented in your system. Okay. So let me same thing I will show in this PyCharm IDE. Let me create Python file, course test.py. So here team, first one, here we are creating SparkContext object. This application is testing the course, not for all team. Okay. So here we are creating Spark master, spark.appname. Just type conf dot. It will display all list of functions team. By using set function, we can set.appname, set.master, or we have set function contains get all, set executor environment, set Spark home. So these are different parameters. Functions are available to. Okay. So get all function, you can get all values. So print get all. Then finally we are passing this configuration object to SparkContext. So this program main intention is to print Spark configuration data type. Then we can use so we are printing all configuration parameters. Let me execute here. Let me show run course test. So it is displaying complete course of our Spark application. Whatever the parameters we set, right, it is displaying all those codes. Okay. So in Spark PyCharm IDE, we set in this way. This is PyCharm IDE. PyCharm IDE, we have to import packages first. Then create a Spark context object. Next, here we are creating Spark configuration object. We are setting parameters. Yes or no? In this way, we set number of core string. Here, if local of star means all processors, sorry, all cores of your processor. How many cores are available in your machine? Let's say here. Let's say localhost colon 4040. So here click on executors. Executors. I will show how many cores my system has. My system has 4-core processor. 4-core processor. We assigned how many cores to Spark application? Here we assigned 2 cores. So instead of all cores, we assigned what? 2 cores to Spark application. Then finally, you can set this one equal to this one to Spark context. So here we set, right? Here we set Spark configuration to context. Yes or no? In this way we set. So if you want to pass parameters manually, then we have to use command line argument. We can read command line argument. We can pass command line argument. So you can pass dynamically. You can pass master name. Dynamically, you can pass application name, etc. using command line argument. Okay. So along with this one thing, there are other important configurations. Other important configurations. Other important configurations of Spark application. So first one thing, let me show conf dot yep, let me write here. So other parameters we can set conf dot set spark dot executor memory. Spark dot executor dot memory. We can set how much RAM you want to allocate for executor. I said in Spark architecture, when you run Spark application, it will create a driver program in a master machine and executor in slave machine. Yes or no? In executor, how much RAM you want to allocate for each executor? How much RAM you want to allocate? So I want to allocate 8 GB. Let's say my each slave contain huge volumes of RAM. I want to allocate my application 8 GB RAM. We can set in this way. And next one, we can set executor cores. Executor dot cores. How many cores you want to allocate for your executor? Say here we are setting master executors. Set master name and number of executors. Then similar way, how many executors you want to allocate for? Sorry, how many cores you want to allocate for executors? I want to allocate 4 cores. So how much minimum I want to 4, maximum how many? How many cores you want? So spark dot cores dot max. Maximum how many cores you want allocated? So this is starting core. Maximum I want 8 cores. My each slave machine contain multiple core processor. So minimum I want allocate 4 cores and maximum I want allocate 8 cores. And how much driver memory you want allocate? How much driver memory you want allocate? Driver I want 8 GB. So like this we can set other configurations also using SparkContext. Okay. So this is very important class. Very important class. By using Spark class, we can allocate a number of cores to executor mission. We can allocate a number of cores to driver mission, or we can set directly Spark.master and number of cores. So you can set in this way, or you can set independently in this way too. Executor we are setting separate memory. Executor we are allocating separate cores, and dodriver we are allocating separate cores. So there are plenty of configurations. So go to SparkConf documentation. Go to SparkConf documentation. Spark documentation. See here, we see Spark documentation too. API documentation. For every language, they given separate API. PySpark package. Here we see SparkContext and SparkConf. SparkConf. Here we have different functions. Set is used to set key value pair. So here we are passing key comma value. So these are different functions of SparkContext, SparkConf. Okay. Understand right? How to set number of cores to Spark application? Let's start. In this session, we are going to discuss partitions. First, what is partition? Partition is a chunk of data. Chunk of data or a small piece of data. A piece of data. Piece of data. So in data, we split the data into multiple partitions. In Spark team, data divided into multiple partitions. A data divided into multiple partitions. Data means partition means a chunk of data or a piece of data. A data is divided into multiple partitions in Spark. Example, let's take HDFS file system. HDFS file system. So loading HDFS file system, loading HDFS file system into Spark. Let's take scenario. Loading HDFS file system into Spark. Then how many partitions are going to create in Spark? Okay, let's say file 1 with the size 300 MB. File 1 with the size 300 MB in HDFS file system. Okay, so 300 MB by 128 MB in HDFS file system. In HDFS file system, block size is 128 MB. Block size is 128 MB. So this 300 MB file divided into multiple blocks. So here we will get 3 blocks. Say block 1 with 128 MB. Block 2 with 128 MB. Block 3 with 44 MB. In HDFS file system, a file is divided into multiple blocks. Each block replicated 3 times. By default, each block replicated 3 times. This is HDFS file system thing. Let's diagrammatically discuss it. So we have one master mission. Okay, one master mission, and we have multiple slave missions. Let's say we have 6 slave missions. Let's say we have 6 slave missions. So total we have 6 slave missions. So this is master mission. These are slaves. Let's say this complete is HDFS file system architecture. HDFS cluster. Let's say this is HDFS cluster. Assume in HDFS cluster they have 6 missions. 6 slave missions, 1 master mission. So file 1 is placed. File 1. So file 1 size is 300 MB. Okay. So here block 1, assume block 1 placed here, block 1, and block 1 placed here. Okay, block 1 placed here, block 1 placed here. So 3 copies of block 1, block 1. Similar way, block 2 is placed here, block 2 is placed here. Okay, and block 2 is placed in this mission. Block 2, so block 2 and block 2, block 2. Then block 3 placed in this mission. Okay, and block 2 placed in this mission. Let's say block 2 placed in this mission. So this is block 2, sorry, block 3. Block 3 placed here, and block 3 placed here, and block 3 placed here. Okay, so we are submitting Spark application. This is our Spark application. We are submitting Spark application. Spark application. Spark app 1. We submitted this Spark application. We submitted this Spark application to process file 1. We submitted this application to process file 1. Let's understand it. Here, it will create a partition here. It will create a partition here. It will create a partition here. For block 1, it will create one partition. Block 2, it will create one partition. Block 3, it will create one partition. So understand it. For each HDFS block, for each HDFS block, it will create, for each unique HDFS block, it will create a partition. It will create a partition. For above HDFS, file 1, it will create 3 partitions. It will create 3 partitions because HDFS file contains 3 blocks. For each block, it will create a partition. For each block, it will create a partition. Okay. Let's say, assume this system is down. Assume this system is down. For block 2 presented in where team, block 2 presented in second mission, fourth mission, and sixth mission, right? So if any mission is down, what is RDD? RDD means recreate, right? Resilient distributed data set. Resilient means recreation. Resilient means recreation. If any partition failed, it will automatically create in equivalent block of other mission. Other missions are presented 4 and 6. So team, it will create partition. It may be in 4 mission, it may be in 6 mission. Assume it is created partition, equivalent partition in 4th mission. Understand, right? So for each block, it will create equivalent partition. For each block, it will create equivalent partition team. Partition means chunk of data. Partition means chunk of data. What is the advantage of partition? We understand what is partition. We understand what is partition. And we understand how it will create partition. how partitions are created. How partitions are created. Next, let's understand advantage of partition. Advantage of partition. Advantage of partition. Main advantage is parallel processing. Main advantage is parallel processing. Parallel processing. It improves performance of the application. It improves performance of the application. So partitions improves performance of the application. It is a chunk of data, actual data. Okay. If it is HDFS file system, for each block it will create equivalent partition. For each block it will create equivalent partition. What about local file system? What about local file system? What about local file system? We understand if it is HDFS file system divided into block. For each block it will create a partition. What about local file system? What about local file system? Okay. So let's take local file system thing. Local file system with some data size. Let's take here we have data directory. In this data directory we have a file. So file contains some data. Let's say open this file. Let's take some data. Let's save this file. See what is the size of this file? 237 KB. So 237 KB. Let's see. Take this file. Extend some more data. Let's check a file size tip. So it is 1865 KB, around 18 MB. Let's say 18 MB, right? 1865 KB means 18 MB. So we are going to load this file. Let's open Jupyter Notebook. Let's go to Workspace, SparkCore. Core. Let's open Jupyter Notebook. Open command prompt. Open PySpark. It will start Jupyter Notebook. Okay, let's start new Python 3. So first one, I want to load file. I want to load file. So R1 equal to means RDD sc dot text file, and file path is, this is our file path or data location. In this data location, we have comment file, comment file, comment.txt file. So we are loading comment.txt file. So when you load this one, it will create RDD. So RDD splits into multiple partitions. Yeah, RDD divided into multiple partitions. Simply we can say a RDD divided into multiple partitions. A RDD divided into multiple partitions. Multiple partitions. How to know? How to know number of partitions? Okay. So see team here. There is one function called getNum partitions. GetNum partitions. So let me execute print R1 dot getNum partitions. GetNum partitions. Let me use T is capital. Let's execute it. So it is showing two partitions. It is showing two partitions. PySpark cell or Jupyter notebook. So when you load file, it is showing two partitions for local file. Okay. Same thing I want to check in PyCharm also. Is this gives the same or not? Let me start PyCharm IDE. It is started PyCharm IDE. Let's create a new project. So let's create a new project. Python file. Partitions test.py. Okay. So up to this Spark context creation and up to this part is same as previous applications. In PyCharm, we have to create everything manually. Application name I am setting Spark Core Partitions test. Okay. So remaining same, creating RDD by loading file, and printing get number of partitions. Right click on this one. Sorry, team. Right click on this one, run partitions test. So understand, right? So simply for local file, it may be Jupyter, it may be anything, PyCharm. For local file, partitions are two. So understanding important point for local file, default partitions are default partitions are 2. So when you load local file into RDD, it will create 2 partitions. It may be any size. By default, it will create 2 partitions for local file. Okay. And what about local collection? What about local collection? Local collection. What about local collection? How it will allocate a number of partitions for local collection? So let's open Jupyter Notebook. Let's create a RDD. So I'm creating R2 RDD equal to sc dot parallelize and pass local collection. I am passing local collection list with some values. Let's say I am passing 5 values. Then I want to display number of partitions of this local file. Local collection RDD. So RDD created based on local collection. I want to know number of partitions created for RDD which created based on local collection. So for local collection, it is created how many partitions? 4 partitions. 4 partitions. By default, for local collection, by default for local collection, PySpark creating 4 partitions. 4 partitions. Per file, it is creating 2 partitions. For local file, it is creating 2 partitions. For local collection, it is creating 4 partitions. 4 partitions. Understand, right? How to increase partitions? How to increase partitions? Let's say I want to increase. My file is big file. I want to increase more partitions so that it process parallelly very faster, right? Yes or no? I want to improve application performance. My intention is I want to improve application performance. So I want to increase the number of partitions. How can we increase the number of partitions? There is a function repartition. Repartition can be used for increasing or decreasing number of partitions. Number of partitions of RDD. So this function can be used for increasing, decreasing number of partitions of RDD. It will return another RDD too. This function returns another RDD. It will return another RDD. So when you increase when you increase RDD partitions, with new partitions, it will return another RDD. Okay. Let's say team, let's say we already loaded this file, right? Let's take another example too. So example 3, this is example 3. In this example 3, what I'm doing, increasing partitions, increasing partitions of RDD. Okay, so let's see team. First I created a RDD by loading file. It may be local collection, it may be HDFS file, it may be local file, it may be local collection, it may be any S3 file. So how can we increase partitions? In this way, first one, R1 dot repartition. I want to 8 partitions. With new partitions team, with new partitions, it is going to return new RDD. Then print R2 dot get num partitions. Observe team. So first R1 partitions are 2. After increasing, how many partitions it is returning? 8 partitions. Yes or no? Example 40. Instead of repartition, we can specify how many partitions we want. How many partitions we want. At the time of file loading. File loading. Let's see. So here, let me take another example. Example 4. So here, while loading only, we can specify how many partitions we want. I want 20 partitions. We can specify at the time of file loading or converting collection. Okay, let's execute. So how many partitions it is showing? 20 partitions. So team, at the time of file loading, we can specify number of partitions. How many partitions we want? We can pass as a second argument for text file function. Same way, example 2, let's see parallelize function. Example 5, let's see parallelize function. So parallelize function, we can specify number of partitions. 10 partitions. We can specify how many partitions we want for RDD at the time of parallelize function, at the time of file loading. Understand, right? So instead of doing repartition, at the time of RDD creation only, we can specify number of partitions. Still, if you want to increase the number of partitions, then we can go for repartitions concept. Okay. Yep. Next one, we can use coalesce function for repartition purpose. Same as repartition, we have another function called coalesce function. By using coalesce function, we can repartition RDD. We can repartition RDD. Let's see team. I written example. First I am loading a file with 10 partitions. By using collage function, I am reducing number of partitions equal to 1. So new RDD contain 1 partition. Okay. So while loading file, I created 10 partitions. I am reducing number of partitions using collage function. Repartition repartition and collage functions can be used for repartitioning a RDD. Repartitioning a RDD. Yep. Let's understand team. Another example. Collage function cannot increase partitions, but repartition function can increase or decrease partitions. Let's use repartition. Repartition can be used for increasing partitions or decreasing partitions. Decreasing partitions. But collage can be used only for decreasing partitions. Let's say here you can use repartition. So it will increase number of partitions. Repartition can be also used for decreasing also. This is repartition. Repartition can be used for increasing, decreasing. Repartition can be used for increasing, decreasing, but collage can be used only for decreasing partitions. Okay. Collage cannot be used for decreasing partitions. But this one, you can use repartition for increasing, decreasing partitions. Repartition can be used for increasing partitions and decreasing partitions. Okay. Understand right thing? Let's start it. In this session, we are going to discuss persistence. What is persistence? First one, what is persistence? So first question, what is persistence? Saving state of an RDD. Saving state of an RDD is called persistence. Saving the state of an RDD is called persistent. RDD can be persisted or persist. RDD can be persist in memory or disk, or in disk. We can persist RDDs in memory or discutive. In serialized or deserialized. In serialized or deserialized mode. In serialized or deserialized mode, and with replica or without replica. So we can save an RDD, we can save or we can persist an RDD in memory or disk in serialized or deserialized mode, and with replica, without replica. So simply we can say saving the state of an RDD in a memory or disk is called persistence. What is the advantage of persistence? Advantage of persistence. What is the advantage of persistence? It improves performance of the application team. It improves performance of the application. Performance of the application. It improves performance of the application. How it will improve performance of the application, we are going to discuss diagrammatically. Okay, so saving the state of an RDD in a memory or disk improves the performance of the application. It avoids loading, prior transformations, and RDD creations, file loading operations. Okay, so when do we persist an RDD? 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 Let's first understand this one diagrammatically. Then we can understand when do we persist an RDD. Okay, let me open Paint. See a team. We are creating R1 RDD. We are creating R1 RDD by loading a file or by loading a file or by converting local collection. Okay, so first one, I am loading a file. So first one is loading file. On this RDD, we are creating R2 RDD. We are applying transformation 1. We are applying transformation 1. 1 minute. So we are applying transformation 1 on RDD 1. Then we got RDD 2. Let's say, so we are applying R1 dot transformation. Transformation may be map transformation, maybe flatMap transformation, maybe reduceByKey, groupByKey, filter, etc. We are applying transformation on RDD. We are getting RDD2. On RDD2, we are applying some transformation. On RDD2, we are applying some transformation. Okay, so we are applying some transformation to transformation 2. Then we got RDD3. So from RDD3, we applied different transformations. From RDD3, we applied different transformations. We got R4. Let's say R3 dot transformation 3. Okay, similar way, we applied one more transformation. We got R5. On R3 only, we applied transformation 4. We got R5. Okay, and R4 we applied transformation. We got R6 equal to R4 dot transformation 1, sorry, transformation 5. And again, we applied one more transformation. We applied one more transformation. We got R7. R7 equal to, we applied R4 dot transformation 6. Transformation 6. So we applied transformation on R4. Then R5 we applied transformation. So we got R8 transformation till we applied on R5. So transformation 7. Transformation 7 we applied. Okay, let's draw flow. On R4 we applied transformation, we got R2. On R2 we applied transformation, we got R3. On R3 we applied two different transformations. Okay, we got different RDD. Then R4 we applied transformation. R4 we applied transformation. We got R6 and R7. R5 we applied transformation. R5 we applied transformation. Let's say this is our application flow. Okay, now on R6 we applied action. R6 we applied action 1. Action 1. And R7 we applied action 2. R7 we applied action 2. R8 we applied action 3. R8 we applied action 3. Okay, so we applied action 3. Let's set it. R6 we applied action, maybe count action, maybe collect action, maybe take action, maybe saving action, etc. Any action we applied on R6, R7 and R8. R8. So without a persistence. So here we are discussing persistence concept. So we are applying persistence concept. Okay. Now let's see team. Now let's see. Now let's see, when you apply action 1, when you apply action 1, what is the flow? When you apply action 1, what is the flow? So action 1 requires R6 RDD. Yes or no? R6 RDD depends upon R4 RDD. R4 RDD. R4 RDD depends upon R3 RDD. R3 RDD depends upon R2 RDD. Yes or no? R2 RDD depends upon R2 RDD depends upon R1 RDD. R1 RDD depends upon file loading. Yes or no? File loading. So this is action 1 flow. Action 1 flow. Next, action 2. Action 2. Action 2 depends upon R7. R7 depends upon R4. R4 depends upon R3. R3 depends on R2. R2 depends upon R1. R1 depends upon file loading. Okay, next action 3. Action 3. So action 3 depends upon R8. R8 depends upon R5 RDD creation. R5 RDD depends upon R3 RDD creation. R3 RDD depends upon R2. R2 depends upon R1 RDD creation. R1 RDD depends upon file loading. File loading. So this is the way actions happen in our flow team without a persistence. Without persistence. Without a persistence. This is the flow. First, what will happen? It will load a file into R1 RDD. So it will create a memory. Okay. Then from R1 RDD, it will create R2 RDD. Once R2 RDD is created, this memory is removed. This R1 memory is removed. Then from R1 RDD, it will create R3 RDD. From R2 RDD, it will create R2 RDD. It will allocate memory. Once memory allocated, then R2 memory released from the RAM. Then from R2, R3, it will create R4. Then memory is allocated. Once memory allocated, it remove R3 memory from RAM. Then from R4, it will create R6. Then it will allocate memory. It will allocate memory for R6. Once R6 memory is created, it will remove this memory. Then from this R6, it will execute action. Depends upon the storage or depends upon the display location, it will print the message string. So this is action 1 flow. Again, same as action 2 flow. File loading into R1, R1 to R2, R2 to R3, R3 to R4, R4 to R6, R7, R7 to action. Same. File loading to R1, R1 to R2, R2 to R3, R3 to R5, R5 to R8, R8 to action 3. In this way, flow is happening without a persistence. Without a persistence. So each action is independent. Each action contain list of RDDs. RDDs flow. Okay. So this is called complete job routine. One job. Every action contain one job. So this information, RDD's information, we can see in first one. To see persistence, we can see persistence in Spark web user interface. First one, we can see persistence in Spark web UI. Spark web UI. In Spark web UI, we see one concept called storage. So first of all, when do we persist an RDD? We are discussing when do we persist an RDD. Where do we see? We know. Where do we see? We are saying we can see persistence information in Spark web UI in menu button storage. If you click on storage, it will show persisted RDD information. Before that, when do we persist an RDD? When do we persist an RDD? If you observe in this flow, without a persistence, what is happening? File is loading, R1 RDD creating, R1 to R2. Once R2 is created, it will removing R1. From R1 to R3. Once R3 is created, it will remove R2. From R3 to R4. Once R3 is created, it will remove R3. You are understanding? Flow is for action. What is the flow created? This concept is called lineage graph. Internally, it will create a lineage graph. So it will maintain complete information of lineage graph. Okay. So this flow executes from file loading to action. Once action is completed, all the flow. See, once file load is created, R1 is created, it will allocate memory. From R2, whenever R2 is created, it will release R1 memory, because team, see, let's say file is 10 GB file. Assume R1 10 GB, filter operation, R2 contain 8 GB, some other operation, R3 contain 6 GB, 5 GB, 4 GB, 3 GB. Assume 10 plus 8 plus 6 plus 4 plus 3. How much GB? It requires more GB if you want to keep all RDDs in memory. Yes or no? If you want to keep all RDDs in memory, it needs more RAM space. That's why Spark will not maintain RDDs in memory. That's why RDDs are lazily evaluated. Lazily evaluated. Whenever we apply action, then only all RDDs loading one by one. Once dependent RDD is created, main RDD memory is released. Who will take in this process? Spark will take in care. Okay. So in this way, what is the problem? If you apply multiple actions, for each action, flow is happening. Yes or no? It is taking more time to execute the flow, because loading file, creating RDD, creating another RDD, removing this RDD. Okay. Now let's coming to point. When do we persist an RDD? If you observe this flow, which RDD mostly used? Many people say R1, R2, R3. R1, R2, R3. And R4 also, R5 also. R6 also, R7 also, R8 also. But that is not the correct answer, friends. Correct answer is, which RDD, question, first listen question, which RDD mostly used in multiple actions? Which RDD mostly used in multiple actions? R1, R2, R3. So in the above diagram, first one, in the diagram, R1, R2, R3, R3 is mostly used in different actions. First one, R1, R2, R3 RDDs. R1, R2, R3 RDDs are mostly used in different actions. First point. As for our observation, R1, R2, R3 is mostly used in 3 actions. If you persist RDD, we say only some performance, not better performance. If you persist R2, we improve little performance. If you persist RDD 3, we improve performance in 3 actions. We avoid creating R1, we avoid creating R2, we save these operations, yes or no? So R3 in this, among these three RDDs, R1, if you persist R1, if we persist R1 RDD, we will improve performance of application team. Performance of application. Understand, right? So first one, when do we persist an RDD? When when RDD mostly used in different actions. When RDD mostly used in different actions, then we will persist. First important point. When do we persist RDD means whenever RDD mostly used in different actions, then we will persist. So in this, which is mostly used RDDs, R1, R2, R3. If you persist RDD 3, we can improve performance of action 1, action 2, action 3. So whenever we persist, what will happen? With persistence, first action 1, with the persistence, action 1 depends upon R6, is depends upon R4, it depends upon R3, depends upon R2, depends upon R1 depends upon file loading. So file is loaded into R1, to R2, to R3. Let's say persist on RDD, persist R3 RDD. So we persisted this R3 RDD in memory. Permanently we persisted. Then from R3, R4 is created, R4 to R6, to action is completed. Now action 2, we are executing action 2. Action 2 depends upon R7, depends upon R4, R4 depends upon R3, is persisted. So from this persisted memory, it will create R4 to R7, to action 2. Similar way, action 3 depends upon R8, depends upon R5, depends upon R3. So simply from this persisted RDD, R5 is created. From R5, R8 is created. From R8, action is executed. Now tell me, team, is performance is increased or not? Can anyone tell me performance of application is improved or not? Without a performance, observe above flow. With the persistence, without a persistence, observe above flow. With the persistence, observe this flow. Is it improved? Yes or no? So at the time of application development, we will write the complete flow of the application. We don't know at the time of application development, we don't know which RDD is going to use mostly in our application. Which RDD is mostly used? RDD. At the time of application, we don't know. After developing complete application, after writing diagram like this, we can easily identify which RDD mostly used in different actions. Yes or no? Which RDD mostly used in different actions. Then we can persist that RDD. In memory. Okay. Let's understand him how to persist an RDD. How to persist an RDD. How to persist an RDD? So PySpark module has storage level class. PySpark module has storage level class. It contains different storage levels. It contains different storage levels. To persist an RDD. We have different storage classes, different storages. In storage level class, we have different storages to persist an RDD. First one, storage level dot memory underscore only. So to persist an RDD, in RAM memory. So second one, storage level, same one, storage level dot memory underscore 2 to persist an RDD in RAM memory with replication 2. So another one, third one. So storage level class contain memory underscore disk only. Storage level dot disk only to persist an RDD in disk memory. So next important one, fourth one, storage level dot disk only underscore 2 to persist an RDD in disk memory with replication 2. And other one team, first, fifth one, storage level dot memory and disk. Memory and disk. To persist an RDD. First it will give priority. Priority, 1 minute. First it will give priority to memory. If memory not available, not available, if memory not available, memory not available team, if memory not available, then it gives priority to disk, priority to disk team. So in this storage level class, first it will give priority to memory. If memory is not available, then it will give priority to disk. Another one, sixth one, storage level dot memory underscore and underscore disk underscore 2. Here same as previous one only. First it will give priority to memory. If memory not available, it gives priority to disk with replica. Okay. So other one. So other techniques we have storage level dot memory underscore and underscore disk underscore serialization form. Serialized form means compression form too. Compression form. It occupies very less space. Serialized form with replication. Serialized form with replication. And storage level dot half underscore heap. It is same as serialized form, but it uses heap memory. So heap memory should be enabled. So these are different to storage level classes. Storage level classes in Spark team. So to persist RDD, we have these many different techniques. Let's start. In this session, we are going to discuss set operators or operations in Spark. So there are 4 set operators. There are 4 set operators or operations in Spark. They are: 1, union operation; second one, intersection operation; third one, subtraction operation; fourth one, Cartesian operation. So total we have 4 set operations. So as part of this set operation, we are going to use one data set. Here we are using example data set is call log data set. In this data set, we have customer care log data. So in this log data, we have failed records, success records, and drop records. Let me open that file. So this is my call log file. So in this call log file, we have dropped records, success records, failed records. Along with this one, we have date and time. Okay, mobile numbers, some other description. Okay, so this file contains some additional information. Okay, along with the dropped status, success status, failed status, it contains date, time, okay, description, and phone numbers. First, let's prepare a data RDDs. First one, let's prepare a RDDs. Let's prepare RDDs. Let's prepare RDDs to perform set operations. Okay. So let me open Jupyter Notebook. Go to workspace, open command prompt, type PySpark. We have already configured Jupyter Notebook with PySpark. So when we type PySpark, it will open Jupyter Notebook. One minute. Let's go to workspace. So let's go to Spark Core. Let's open command prompt. Let's type PySpark. Click on new, type Python 3. Then first one, preparing RDDs. Preparing RDDs. First one, I am loading file R1 equal to sc.text file. sc.text file. Load the input file, data file. So go to data directory, copy this path. File name is call log.txt. Inside double quote, we have to use two backward slashes, because if you use only one backward slash, it will expect a formatting characters like slash and slash t. So we are giving indication to Python. It is not formatting character purpose. It is a path separator. That's why we added two slashes. Now let me print count of this RDD, total records of call log data. So total records we have 206 records. Okay, let me display print total records. Total records are R1 dot count. R1 dot count. Okay. Next one, print number of partitions. Default number of partitions. Default number of partitions are R1 dot get num partitions. Get num partitions. Now I am displaying path separator, results separator. So star into 50 times. Let me display. So it is loading file and finding count, and number of partitions are 2. Okay. So now I want to filter from this. I want to filter failed records, success records, and drop records. Let's say success RDD. Success RDD equal to R1 dot filter lambda x colon. Let me search the success content. Copy this success content. So we want to search only success records. Success in X. So whenever it finds a success in X, it will return that success records. So similar way, I want to print count of success records and default partitions of success records. Success RDD records are success RDD, default success RDD, number of partitions are. So success dot count R1 dot get num partitions. Sorry, success RDD dot get num partitions. Similar way, I am finding failed RDD, I am finding dropped RDD. So failed RDD. So let me copy the content, failed content, and use this one in search operation. Okay, then search failed RDD records are failed RDD dot count, default failed RDD number of partitions, default failed RDD partitions. Similar way, dropped. So let's search the string, dropped string, and use this dropped string in searching filtering operation. Okay, dropped RDD records are dropped RDD count, default dropped number of partitions are drop records dot get num partitions. Let's execute this one team. So total records are 206, default number of partitions are 2, and total success records are 155, default partitions are 2. Failed records are 23, default number of partitions are 2. Drop records are 28, and default number of partitions are 2. Let's use this one. Okay, I want increase partitions of success RDD, failed RDD, and dropped RDD. Let's say S equal to success RDD dot repartition. Success RDD dot repartition. I want to make it as 10 partitions. Similar way, failed partitions I want to increase, and similar way I want to increase dropped partitions. F equal to failed RDD dot repartition. Failed RDD dot repartition, I want 8 partitions. And next one, D equal to dropped RDD dot repartition. Dropped RDD I am repartitioning to 5. So after repartition, let's say print after repartition total success RDD partitions. Success RDD partitions. Success RDD partitions. So yes dot get num partitions. Next one, failed RDD partitions. After repartition, failed RDD partitions. F dot get num partition. Next one, after repartition, dropped RDD partitions are D dot get num partition. Okay. So after this, I am displaying start 50 times. Let's execute, shift enter. So before repartition, all RDD's partitions are 2 because we are loading local file. If you load local file, default partitions are 2. So based on R1 RDD, we are creating success RDD, failed RDD, dropped RDD. So whatever the parent RDD contain, same partitions child RDDs gets. So we repartition success RDD, failed RDD, dropped RDD. When you apply repartition, it will return another RDD. That's why we used different variables to store success RDD, failed RDD, dropped RDD. So we prepared data type. We prepare RDDs. Okay. Now let's start union operation or union RDD. Union operation or operator merges two or more RDDs, two or more RDDs, and returns results which may contain duplicates, which may contain duplicate records. In SQL, we have union and union all. See, union operation returns union merges two or more select queries, two or more select queries, and returns what? Returns unique values. In SQL, union merges are two or more select queries, and returns unique values. Union all merges two or more select queries, and returns results which may contain duplicates, contain duplicate string. But in Spark we have only union. Operation. It merges two or more RDDs, and returns results. Two or more RDDs returns results which may contain duplicates, Okay. Let's see example. We have set A contain 1, 2, 3, 4, and we have set B contain 3, 4, 5, 6. We are performing A union B. Equal to, it will return output is 1, 2, 3, 4, 3, 4, 5, 6. It will return results in this way, team. Okay, let's implement the team. Let's implement union operation. Union operation. So we have failed RDD, we have success RDD, we have dropped RDD. Let's say, so first one, I want to perform union operation of failed RDD and dropped RDD. So let me print count of dropped RDD, count of failed RDD. So let me print failed RDD records are f dot count and failed RDD count. Next one, dropped RDD count. Failed RDD number of partitions, dropped RDD number of partitions. D dot count, D dot get number of partitions. Before merging, I am displaying count of failed RDD, number of partitions of failed RDD, count of dropped RDD, number of partitions of dropped RDD. Okay, so then I am performing union operation. Union RDD equal to failed dot union of dropped. Now let's say team, I want to display union RDD count. Union RDD count. Union RDD records dot count. Next one, union RDD number of partitions. Union RDD dot number of get num partitions. So we calculated union operation. Then we are performing union RDD count. Let's say team, total fail RDD count is how much? 23. So number of partitions are 8. So this one dropped RDD count is 28 and number of partitions are 5. So what about union RDD count? So 28 plus 23, that is 51 records. What about this number of partitions? 8 partitions plus 5, that is 13 partitions. Let's execute it. Let's see. It is displaying count of failed RDD and failed RDD partitions, dropped RDD records count, dropped RDD partitions. Now it is performing union operation. Once union operation is completed, it displays union RDD count is 51. Union RDD partitions are 13. Understand, right, team? So union operation returns results which may contain duplicates, team. Which may contain duplicates. So this is example 1. Let me take one more example for union operation. Example 2. So let me take another example. Let's say team. So I am taking so this one total records are R1 dot count. So total records are 206. In this we have drop records, right? Yes or no? So total records number of partitions are 2. Yes or no? So drop records are 28. Already we have 28 records in 206. So again we are performing R1 dot R1 dot union of D. Then so 206 plus 28. Tell me how many records? 234, right? 234, which includes 28 duplicate records. 2 plus 5. So total how many partitions? 7 partitions. Let me execute. Sorry, here we have to use R1 dot get num partitions. Let me once again execute. Shift enter. So total records are 206. Total number of partitions are 2. Dropped RDD records are 28. Dropped RDD number of partitions are 5. Now it is performing union operation. So 2086 plus 28, 234 records. 2 partitions plus 5 partitions, total 7 partitions. Understand, right, team? Union operation merges 2 or more records, returns results. That result may be contain duplicate records. Understand, right, team? What is union RDD? What is union RDD or union operation? Yep. Let's start, team. We discussed what are set operators available in Spark. We have 4 operators: union, intersection, subtraction, Cartesian, and we discussed preparing RDDs. First we prepared RDDs. Let's see. First we prepared RDDs. Next, after preparing RDDs, we discussed what is union operation. Differences with in SQL, we have union and union all. In Spark, we have only union operation. In Spark, we have only union operation. In Spark, union operation merges two or more RDDs, and returns return results including duplicates. Okay, so we seen union operation. Now let's understand subtraction. Now let's understand, sorry, intersection. What is intersection? Intersection can be applied on 2 or more RDDs. Okay, we can apply intersection on 2 or more RDDs and returns only elements from First data set, only elements, unique elements, only unique elements. Unique elements from first data set. It will return unique elements from first data set. Example, we have data sets in this way. We taken data set 1, data set 1 with 1, 2, 3, data set 2, 3, 4, 5, 6. A intersection B. Then we will get only unique values from first data set, that is 2, 3. Sorry, both data sets unique values. In both the data sets, unique values are 3, 4. 3, 4. Okay, so let's see it. Practical implementation. Let me take intersection operation. So first we are printing total RDD records and total RDD partitions. Total RDD partitions are 2. Now I am printing dropped RDD records count and dropped RDD number of partitions. So dropped RDD partitions are 5. Then here intersect RDD. Intersection RDD equal to R1 dot intersection of dropped RDD. So I am printing total count of intersection RDD. So intersection RDD count. Then intersection RDD partitions. Too. Let's observe what is the value of intersection RDD partitions. So here intersection RDD results is total 28 records. Yes or no? Intersection RDD records are, so unique records 28. 28 common records. Yes or no? Let's execute this one. Let's observe. So total RDD records are 206, partitions are 2, dropped RDD records are 28, and partitions are 5. It is performing intersection operation, and intersection RDD records are 28, and intersection RDD number of partitions are 2 plus 5. 2 plus 5, that is 7. Yes or no? So intersection also number of partitions, it is applying addition. So first RDD partitions plus second RDD partitions. So it will create new partitions for intersection RDD. So understand, right? Intersection RDD. Now let's understand subtract. What is subtract? Subtract operation. Subtract operation. So subtract operation is subtract operation. Subtract operation returns the elements returns the elements from one data set. Returns the elements from one data set. First data set by taking away all the matched elements. By taking away all the matched elements. Elements from second data set. Second data set. Let's discuss. Let's take an example. So we have two data sets. So when we say subtract A subtract B, it will return. So first it will subtract common elements from both the data sets and returns from first data set, it will returns elements, that is 1, 2. After subtracting second data set elements from first data set, so it removed 3, 4 from first data set, returned only 1, 2. Okay, let's see team subtraction operation. So let's take same example. So here let's take subtraction operation. So from total records are 206, number of partitions are 2, drop records are 28, drop records partitions count is 5. So subtraction RDD equal to R1 dot subtract and we are using drop record count. So from 208 it will subtract common 28 records. Now tell me how many records it will come. 190 2 na. Tell me what is the count. Let's execute. Let's see. 180 na? No man. 206 minus 28. 192. Let's execute. So total records, total number of partitions, drop records count, drop record partitions, it is performing subtraction. And 178 and the number of partitions for subtraction RDD is 7. Let's understand output. See the output. Now we understand, right? What is subtraction RDD? It eliminated second RDD duplicate values. Second RDD duplicate values from first RDD. Second RDD values from first RDD returned new values to subtract RDD. So subtract RDD partitions are first RDD partitions plus second RDD partitions. Okay. Now let's understand Cartesian product. Cartesian. So Cartesian means multiplying first data set records with second data set. Multiplying first data set each record with second data set. It is a costly operation. It is a costly operation because it occupies more processing. Sorry, it takes more processing and it occupies more memory. Cost means it takes more processing and more memory. So unless business required to perform, we need Cartesian product, then only we can use Cartesian product. Otherwise, testing purpose, it is never recommended to apply on huge volumes of data. Small volumes of data, okay. But if it is huge volumes of data, if you apply Cartesian product, what will happen? Each record of first data set multiply with each record of second data set. Example, let's say we have A equal to 1, 2, B equal to 3, 4. Okay, let's say we are performing A Cartesian B equal to so it will perform like 1, 3. First one 1, 3. Next it will perform 1, 4. Next it will perform 2, 3. Next it will perform 2, 4. So each element of first record multiply with each element of second record. Let's see practicality, and partitions also it will increase. Let's say I'm using fail RDD multiply with dropped RDD. So Cartesian operation. Fail RDD count is 23. Fail RDD number of partitions are 8. Dropped RDD count is 28. Dropped RDD number of partitions are 5. Now Cartesian RDD. So F dot Cartesian. F dot Cartesian of D. Now Cartesian RDD count. So that is 23 into 28. 23 into 28. And Cartesian RDD count multiply with the first RDD into second RDD. Cartesian RDD number of partitions. So 8 into 5. Let's observe. Shift enter. So file RDD it is displaying. Dropped RDD it is displaying, and it is performing Cartesian operation. Here we have 23 records into 28. So it may take few minutes. If it is a huge volumes of data, it may take longer time. It utilizes more CPU processing power. It utilizes more RAM. Okay. So total records are 644. 8 into 5, 40 partitions. Understand right thing? So that's it for set operations in Spark. So total we have 4 set operators: union operator, intersection operator, subtraction operator, Cartesian operators. So we discussed all these operators one by one. Okay. Any queries up to now, team? No, na? Yeah. Let's understand it. In this session, we are going to discuss aggregation operations in Spark. First, let's understand aggregation operations. Aggregation operations in SQL. So aggregation operations in SQL. So we have sum aggregation, we have count aggregation, we have max aggregation, we have min aggregation, we have average aggregation. So total 5 aggregations. Total 5 aggregations. 5 aggregation operators. 5 aggregation operators or operations. So total 5 aggregation operators or operations in SQL team. But in Spark, aggregation operators are operations. But in Spark, aggregation operators are 3. They are first one reduce, second one fold, third one aggregate. So total we have 3 aggregation functions. 3 aggregation functions. Okay. In these 3 aggregation functions, reduce and fold works fold works or applies partition level or result of partition level and result of partition level partition level, same operations but aggregate function aggregate operation applies partition level different operations and results of partition level and result of partition level it applies different operations too. Partition level it applies different operation, result of partition level it applies different operation. Okay, so one important rule it follows: aggregation operations follows cumulative law. Aggregation operations follows cumulative law. What is cumulative law? So cumulative law means A plus B equal to B plus A. Yes or no? A into B equal to B into A. Yes or no? It means, to assume your data sets having multiple partitions. Your RDD or data set having multiple partitions, 10 partitions. We don't know first partition may complete first or 10th partition may complete last, or 10th partition may complete first partition may complete last. We don't know which partition completes first, we don't know, but it has to satisfy final output should be same. So all these reduce, fold, aggregate operation follows cumulative law. Okay. Let's start understanding reduce aggregation. So first one thing, understand syntax of reduce aggregation. Reduce. First it will take function as a element. Reduce takes function as a argument. It will take argument is function. Reduce function argument is function type. So we use RDD dot reduce and argument is function. On each element of RDD or each row of RDD, it will pass as an input to this function. Each element of RDD, it will pass as an argument to this function. Let's see practically implementation of RDD. Let's take example. Let's take example. So we have values. We have values 1 to 10. We have a list of values. Let's say 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So total we have values 10. 1 to 10. 1 to 10. Let's practically see it. Let's see team. We are creating RDD R1 reduce aggregation. We are creating R1 RDD equal to SparkContext dot parallelize function. Sorry, we have range function. First element is 10. Start from 10 and values between. Start element is 1 and generate a range of values between 1 to 10 and number of incrementation is 1. Each element increment by 1 like this. Start with 1, each element increment by 2. So between 1 to 10, between 1 to 10 means 1 to 9. Okay, it is created range and number of partitions equal to 2. So here, let's understand here. So here we are calling range function. Range function, we are saying start, end, increment, and number of partitions. So we are passing arguments to range function, start value, end value, increment value, number of partitions. So total it will create how many partitions? 2 partitions. Okay. So now first I am displaying values of R1. Before performing reduce operation, I am displaying values of R1 for V in R1 dot collect. Printing each element of R1. Let me execute. Print V, not R1. So 1 to 9 values we printed. Now let's apply reduce operation. So R1 dot reduce, and here I am writing function lambda x comma y colon I am applying x plus y, and it will return another RDD. I am storing another RDD. Now finally display values of R2 RDD. Display values of R2 RDD. R2 dot collect. See the output. So this is not a result. Another RDD. It will return R1 or reduce. Let's say result. So let's display result. Print result. Reduce result type. Let's say shift enter. So total we got what? 45. Let me print print star into 10 times. So we got output is 45. Understand what will happen here. Let's say first RDD divided into two partitions. So 1, 2, 3, 4, 5. So first partition, assume first partition is having 5 elements, and second partition contain 6, 7, 8, 9. Assume we have a 4 elements. This is partition 1. This is partition 2. So partition level, first x value. First it will take x equal to 1 here, and y equal to 2. In this partition, x equal to 6, and y equal to 7. So first one, 1 plus 2. So it will return what? 3. 3 it will store in x, and y value become 3. 3 plus 3, 6. 6 it will store in x plus 4. 6 plus 4, that is 10. 10 plus 5. What is the value? 15. So first partition result. Coming to second partition, 6 plus 7. What is the value? 6 plus 7. What is the value? 13. 13 stores in x. Y value become 8. 13 plus 8. What is the value? 21. 21 stores into x. Then 21 plus 9. 9 stores into y. 21 plus 9. That is 30, right? So this is partition 1 result. Next one, partition 2 result. So again, x value become here. Partition 1 value become x value. Partition 2 value become y value. So 15 plus 30. So that is output value is 45. So that's why I said, so this is partition level operations. These are partition level operation result, and result of partition. Also applied what? Same operation. Partition level it applied same operation. Result of partition level it applied same operation. That's why we are saying reduce, fold applies partition level same logic, result of partition level same logic. After understanding fold, you also understand partition level it applies the same operation, result of partition level also it applies the same operation. Understand, right team? What is happen partition level? What is happen result of partition level? Partition level it applied addition operation, whatever the custom logic we written. Result of partition level also it applied same custom logic. let me copy this one. Let's understand fold operation as part of aggregation operations in Spark. We understand reduce operation. Now let's understand fold operation. Fold is same as reduce. Fold is same as reduce operation, team, but fold operation function takes two parameters. Let's see syntax. Fold, let's say RDD dot fold. It will take first argument is initial value, initial underscore value, comma, function as a argument. It will take two parameters, initial value and function as a argument. Let's see fold operation. Same thing I am taking to fold. Observe what is the difference between fold and reduce function. So first I am creating range function. Okay, first I am creating range function, and next I am going to take I am printing values from R1 RDD. Now I am applying fold operation. Okay, but fold operation taking two parameters. First parameter is initial value. Let's say initial value I am passing 2. Initial value I am passing 2. Let's see fold underscore result. Then I am printing fold underscore result. Let's execute it. So we got value output is 51. Let's understand diagrammatically. So first we have two partitions, 1 comma 2 comma 3 comma 4 comma 5. So first partition values are this. Next partition value 6 comma 7 comma 8 comma 9. So second partition value. So this is partition 1, because we said the two partitions. That's why it is created two partitions. Partition 2. So this is partition 2. Okay. So we said initial value equal to 2. So here x value, it will take initial value equal to 2. And y value it will take first element of partition, that is 1. Here also it will take initial value equal to x value, it will take 2. Y value it will take first element of list. Okay. So 2 plus 1, that is 2 plus 1, that is 3. 3 plus 2, that is 5. 5 stores in X, 5 plus 3, 8. 8 plus 4, 12. 12 plus 5, 12 plus 5, 17. So this is first partition result. And here coming to X value is 2, 2 plus 6, that is 8. 8 plus 7, 8 plus 7, how much? 15. 15 plus 8. 15 plus 8, 23. 23 plus 9, how much? 23 plus 9, 30, 32. Now this is partition to result. Again it applies x equal to 2 and y equal to 17. Y equal to 17. So 2 plus 17, how much? 2 plus 17, how much team? 19. 19 plus 32. 19 plus 32, how much? Tell me team. 51. So this is result of partitions. Yes or no? So partition level it applies addition operation. Result of partition level also it applies. It applied. Result of partition also it applied what? Addition operation. That's why reduce fold function applies. Partition level same operation. Result of partition level same operation. Let's copy this logic. Let's copy output. Now let's understand aggregate operation. Reduce, comma, fold, applies, partition level, and result of partition level, same operation, same operations, but aggregate operation applies partition level, different operation, result of partition level different operation. Result of partition level, result of partition level, different operations, different operation. Result of partition level is different operation. Let's see syntax team so that you will understand syntax. So RDD dot aggregate, RDD dot aggregate. So it will take first initial value, initial underscore value. Next it will take function 1 as an argument. Next it will take function 2 as an argument. So total it will take 3 parameters. 3 parameters. Here partition level, it applies function 1. Result of partition level, it applies function 2. Result of partition level, it applies function 2. So very important point. Partition level it will call function 1. Result of partition level it will call function 2. Let's practically see example. Same thing I am taking. So here I am using aggregate operation. So first I am taking sc dot range 1, 10, increment by 1, number of partitions are 2. Now I am using aggregate result. So here we are applying aggregate function. So first one it will take initial value. Next we take function 1. So this is function 1 output. So after function 1 output, again we are going to take one more function. So lambda x comma y. You can take same names or you can take different names for parameters names. A comma b colon a into b. So this one applies partition level. So this one applies result of partition level. Result of partition level team. So here partition level we are applying. Addition operation. Result of partition level we are applying multiplication operation. Okay. So let's execute this one and see the output. So we got output is triple 8. So what is happened here? So total we have two partitions. So first partition is, let's say first partition is 1 comma 2 comma 3 comma 4. Let's say first partition we have values are in this way. Second partition we have 5 comma 6 comma 7 comma 8 comma 9. Assume values we have in this way. So assume we have two partitions, partition 1, partition 2, partition 1 and partition 2. So initial value x equal to what? Initial value equal to 2. Yes or no? Y equal to, we set initial value 1 here. Here x equal to initial value 2. Initial value 2. Y equal to, here initial value equal to 5. Initial value equal to 5. So 2 plus 1. 2 plus 1. We got to 3. 3 plus 1. Sorry, 3 plus 2. We will get 5. 5 plus 3. 8. Let's say 8. 8 plus 4. That is 12. That is 12. So coming to here, 2 plus 5. 2 plus 5 is 7. 7 plus 6. That is 13. 13 plus 7. That is 21. Yes or no? Sorry. 13 plus 7, 20. Right? 20 plus 8. 20 plus 8. That is 28. 28 plus, tell me team, 9. 37. 37. So this is first partition result. This is second partition result. Partition level we are performing addition operation. Addition operation. Partition level we are performing addition operation. So first function is addition. Yes or no? Next one. So here initial value x equal to 2. X equal to 2. So y equal to 12. 12. So 2 into 12 into 37. Final result is 888. So result of partition level, we are applying multiplication. Multiplication. Result of partition level, we are using multiplication thing. Understand, right? Partition level different operation. Result of partition level different operation. We call it as aggregation operation. Two different operations. Understand, right thing? Let me open calculator. So 2 into 12 into 37 equal to 488. Okay, in this way it will perform aggregation operation. Partition level different operation, result of partition level different operation. Yep, that's it for aggregation operation step. Let's start it. In this session, we are going to discuss pair RDD. Pair RDD. What is pair RDD? Any idea? So a RDD with key comma value, key comma value pair. A RDD with key comma value pair we can call pair RDD. Pair RDD. A RDD with key value pair as a rows or values. Okay, let's take one simple example to understand pair RDD. Let's take simple example. So I am creating one RDD R1 equal to sc dot parallelize. I am passing collection. So first I am creating a RDD. Once RDD is created, I am converting each row of RDD with key value pair. Each row of RDD with key value pair. R2 equal to R1 dot map lambda x colon x of 10, x comma 10. Yep, this one converts key value pair. So first one, let's display R1 RDD. So for v in R2 dot collect colon print v. Okay, so we are printing key value pair, and before that let me print type of R1 and print type of R2. Print type of R2. Print type of R1, print type of R2. So R1 type is RDD type, R2 type is pipelined RDD. Okay, so next one we printed R2 RDD data. So it is printing key value pair format. Yes or no? So printing complete pair RDD data. Printing so pair RDD data. Pair RDD data we are printing. Next one, see once pair RDD is created, we can apply operations on key level and value level. So main advantage of key value pair is we can apply operations on key level and value level. So let's understand. Let me copy this one. On pair RDD, we can apply two kinds of operations. Two kinds of operations. They are key level, one key level, and two value level. Key level operations and value level operations. Okay, so let's see. So we can apply key level, value level. So I want to print count by key, R2 dot count by key, R2 dot count by value. So key level thing. 1 repeated how many times? 1 time. 2 repeated how many times? 1 time. 3 repeated how many times? 1 time. 4 repeated 1 time. 5 repeated 1 time. 6 repeated 1 time. Coming to value, value means key value pair. So this entire is key value pair is repeated 1 time. 2 comma 10 is repeated 1 time. 3 comma 10 is repeated 1 time. 4 comma 10 repeated 1 time. 5 comma 10 repeated 1 time. 6 comma 10 repeated 1 time. I want to print only keys. So first one, counting value level operations, key level operations. Example 1. Let's see example 2. I want to display only keys. Let's see, to print only keys. Then we use for v in R2 dot keys. Keys is a function. Then print v. Yep. First one, we have to use keys function in this waiting. Keys equal to R2 dot keys, then keys dot collect. By using collect functions only, we can iterate it. So we are printing only keys. It will print all keys. Next, I want to print values. Value string. To print only values. Next, example 3, to print only values. To print only values. We use for R2 dot. So before that, let's first create a values equal to R2 dot values function. Then for V in values dot collect function. Then print V. It prints only value string. So key level we can apply separately. Value level we can apply separately. We can read only keys. We can read only values. We can count key level and value level. If you have data in this format, we can apply key level operations and value level operations string. I'm giving one simple example. So try this example. I have a tuple team. So tuple contain different records. Let's say this tuple contain different records. Tuple 1 and employee number, employee name, or employee name, employee gender, okay, employee salary. Similar way, we have another tuple. So tuple inside a tuple. We have multiple tuples. Female N2 and 15,000. So next one N3 male and 40,000. And next one N4 female, some 35,000. So this is my tuple data. So requirement is create a pair RDD, and find female records. Find female records. Okay. Second one, first question 1. Find female records. Question 2. Find male records. Next question. Print male records. Whose salary greater than 30,000. Next one, find sum of salaries of employees gender wise. So find sum of salaries of employees gender wise. This is our tuple. So take this tuple and find these question string. Okay. Let's start a Spark session. In Spark 2.0, in Spark 2.0, they introduced Spark session. Spark session team. Instead of creating creating multiple objects, creating multiple objects like SparkConf, Spark context, SQL context, and Hive context, Apache given Spark session, Apache introduced Spark session type, Apache introduced Spark session. So instead of creating multiple objects, you can create a single Spark session object. Whatever the context object you want, you can get that context object using Spark session. So inside Spark session context, Spark session object or Spark session class, they have already created objects to SparkConf context, SQL context, Hive context. No need to create manually. You can use single Spark session object to get any of above context. So this class was introduced in Spark 2.0. Okay. Let's see how to create Spark context object. Sorry, how to create a Spark session object. How to create Spark session object. How to create Spark session object. First one, we need to import one package. Import one package. From PySpark.sql package. In this package, we have Spark session class. Import Spark session. So first we need to import this class. After importing this class, we will create a Spark context object. We will create Spark session object, not context object. Spark session object in this way. Spark equal to Spark session dot builder dot master, and we will specify master name. So you can specify master name. So I want local master. Okay. After setting master name, you can set up application name. If you want to set up application name, you can set up application name type dot app name. Then you can set up application name. First app. Next one. Here we use one option, enable Hive support. If you want to enable Hive support, we use dot. Let's say I'm using slash to continue. Next line, dot enable Hive support. To enable Hive, we use enable Hive support. Okay. Then we use function called get or create. So this statement will create a Spark context object. Spark session object. So this one creates what? Spark session object. So once we got the Spark session object, we can create RDD, or we can create data frame by using Spark session. By using Spark session, we can create RDDs. We can create RDDs, and we can create RDDs or data frames, etc. We can create RDDs, data frames, etc. One important to note, in interactive mode, that is PySpark cell or Jupyter notebook, Spark session already created. Spark session is already created. So no need to create manually. If you are directly writing script using Notepad or IDs like PyCharm, we have to create Spark session object in this way. But in Jupyter notebook, if you start PySpark cell using Jupyter, okay, here Spark is already created. Print Spark. So it will show Spark session object information. Let's wait. It will print the Spark session. Yep. Once again, let's execute. Yep, it is printing Spark session object. So by default, Spark session object is created in PySpark cell. No need to create manually. It is already created. No need to create manually. Okay. I want to create an RDD. Create RDD using Spark session. Here we can use two ways, team. Two ways. Two ways to create. Let's observe. Let's observe it. First one, SC equal to Spark dot SQL context. Spark dot SQL context. So first we are creating separate variable. Okay. Next one, R1 equal to SC dot text file or parallelize function, and I am passing collection. Okay. Now I am print R1 dot count. Let's execute. Sorry. not SQL context, Spark context, Spark context. So we got to count is 5. This is wave 1. Wave 1. So instead of creating separate variable, you can directly use way 2. You can use direct way 2. So you can directly use this one thing. You can use spark.sql spark context, and you can directly call parallelize function. Okay, parallelize function, and or you can call text file function or whole text file function. So it is giving count 6. Yes or no? So you can use directly. You can use directly spark context, and you can call any spark context functions. Spark context variable. This variable is already presented in Spark session class. So this variable you can directly call. Instead of creating Spark context thing, you can directly call spark context. Dot you can call any Spark context functions. So in this way we can create RDDs using Spark session. So in latest versions, most of the people uses Spark session. So if you want to use a Spark session, replace all our programs in this waiting. For creating RDD, replace all our previous programs with this kind of statements. Okay. So Spark session is a predefined class which is presented in PySpark.sql package. SQL package. By using this Spark session, we can create a instead of creating Spark context, SQL context, and Hive context, we can use single variable to perform all these operations. Okay. So they avoided multiple variables creation. Yeah. So that's it for Spark session team. Yep. Spark session example using PyCharm IDE. Spark session example using PyCharm IDE. So I said in Jupyter notebook, simply we can say PySpark cell, Spark session object already created. If it is a PyCharm IDE, we will create a Spark session object in this way. Then remaining steps are same. Let's execute this one. Right click on this one, run Spark session test. So it is printing complete logs. So if you don't want to log, then set log level using spark context dot set log level warning. That's it. Now let's execute. Run Spark test. In PySpark cell, Spark session is already created. In PyCharm IDE, we are creating using this statement. Okay, yeah, copy this one. Interactive mode, Spark session is already created, but the script mode, we have to create Spark session. Okay, let's see implementation team. Implementation. I said we can see persisted RDD information in. We can see persisted RDD information in Spark web user interface. We started PySpark. It is opened Jupyter notebook. So parallelly we can open what? Localhost colon 4040. So this is Spark web UI. Click on storage. Then we can see persisted RDD information here. We can see persisted RDD information here. Okay. So first one, loading a file. So let me load a file. I am creating R1 equal to sc.text file function and load a file. So we have data directory here in PySpark, data directory. So this is our file. I am loading this file, comment.txt. Okay. So I am loading this file, creating RDD. So creating RDD. Now what I am doing, persistent RDD. So to persistent RDD, we need to import first package what? We need to import package. So from PySpark, import storage level class. Import to storage level class. So I want to persist an RDD. R1 dot, there is one predefined function persist. Here we use storage level dot memory underscore only. Okay, execute this program to first example one. So this is our example one. After persisting, verify Spark web UI. Verify Spark web UI. Okay. So let's execute to shift enter. RDD persisted successfully. Go to web user interface. Go to Spark web user interface. Refresh. Still it is not showing persisted RDD information. Why? Why it is not showing persisted RDD information? Still we are not seeing persisted RDD info. Why? Because we did not apply action. We did not apply any action. Yes or no? We did not apply any action. So unless we apply action, RDD will not load into memory, right? Yes or no? Go to Jupyter notebook, apply R1 dot count. R1 dot count, shift enter. R1 count displaying comment data. Let's go browser. Let's see. So this is RDD. RDD persisted. This is RDD. RDD name persisted in memory. Serialization default is 1x. Memory serialized, but 1x means there is no replica, only one replica. There is no duplicate copy. So it is persisted in memory serialized form. So we have to apply what? Persist. We have to apply any action. So apply action, verify. Apply action and verify. Verify. Okay, example 2. Example 2. I want to persist RDD in disk. Persist RDD in disk memory. So this is our requirement, disk memory. So what we are doing, already RDD is created. Yes or no? Already RDD is created. So I am planning to persist RDD in disk only. Persist RDD in disk only. Let's execute shift enter. Shift enter. We are going to get error. Storage level dot disk only. Let's see. Refresh. How? It is created another RDD. So what I'm doing, separate cell I executed, right? Again I loaded, right? So instead of this, what I'm going to do, let me remove here. Sorry. So what I'm doing, R1 dot, let's say here I'm doing persisting. R1 dot persist, disk memory I'm using. Disk memory, shift enter, or at least execute count, shift enter. Let's observe, we are going to get error. Let me try to execute this one. We are going to get error saying unsupported error, py4j error, unsupported error, and it is giving error message saying RDD already persisted. RDD already persisted. You are trying to persist to same RDD. So if you try to persist to same RDD, we will get error. So what we have to do, comment this one. So before applying this one, first we need to unpersist. R1 dot unpersist. Unpersist. Then you can repersist. It will work. Now it is working. So we have to do what? We have to unpersist and repersist. Unpersist, RDD1 and repersist. Go browser, refresh. So unpersist is not work. What I'm doing? So first one, R1 dot unpersist. shift enter. So we restarted kernel, we re-executed. Once again, I am executing this one. Let's go cell. Here it is showing memory serialized, replicated, refresh. So memory, disk serialized. CT. So first I executed this one. Next I executed unpersist, then serialized. It replaced with memory to disk serialized. Let's say I want to persist an RDD, memory and disk. Memory underscore and underscore disk. First I am unpersisting. Next example 3. Example 3. Memory and disk. Let's execute it. Shift enter. So refresh. So disk memory serialized. 1x replicated means it is given first priority to memory. If memory not available, it will give priority to disk with replication. Let me copy this one. Let's execute with replication. With replication. So let's observe first before executing this one. Let's observe T in Spark Web UI. It is 1x replicated, only one copy. Let's execute this one. Let's go browser, refresh. So it is 2 replicated, 2 copies. Maximum you can take only 2 copies. Then apply other storage levels also too. Apply other storage levels and observe. Okay. So that's it for persistence concept.